Yes, mute. ଏଇଟାକୁ ଆଉ ଏଇଟା କଣ କରୁଛନ୍ତି ସାର୍? ମୁଁ ତ କଥା ଲାଗି
ସେମାନେ ଶୁଣିପାରୁଥିବେ ନା ସାର୍? ଶୁଣିପାରୁଛନ୍ତି ମୋ କଥା? ତାହେଲେ ଠିକ୍ ଅଛି।
ଶୁଣିପାରୁଛି ସାର୍।
ଦିଲ୍ଲୀପ ସାର୍, ସାର୍ ମୋ କଥା ଶୁଭୁଛି ତ?
ହଁ ଶୁଭୁଛି।
କିଏ ଇଏ କହୁଛନ୍ତି କି ଆମର ଜଗନ୍ନାଥ ସାର୍?
ମୁଁ ସାର୍ ରାମ ସାର୍ କହୁଥିଲି, ରାମ ସାର୍ କହୁଥିଲି ଇଏରୁ। ସାର୍ ଶୁଭୁଛି କି ମୋ କଥା?
ଆଉ କିଛି କରିବା ନାହିଁ, ଯିଏ କହିବ ସେ ସ୍କ୍ରିନ୍ ଆସିବ। ଏଇଟା କଣ କରୁଛନ୍ତି?
ନମସ୍କାର। ହଁ ନମସ୍କାର, ଆରମ୍ଭ କରିବା।
No madam, 9:30 AM.
9:15 କହୁଥିଲେ।
9:30.
9:30।
Okay madam, 9:30.
ଆଚ୍ଛା ଆଚ୍ଛା ଠିକ ଅଛି।
ହଁ 9:30 madam. ଏଇଠି ଏପଟେ ଛିଡ଼ା ହେଇଥାଉ ତ କୋଉଠି
ଓ 9:15 ଆପଣ କହିଦେଇଛନ୍ତି ନା?
ସାର୍ ମାଉସ ଅଛି କି ସାର୍? ସେ ୟା ପରେ ମାନେ ଯେ ମଝିରେ ମଝିରେ
ହଁ ହ୍ୟାଲୋ। हेडफोन न दे
Don't speak.
हेलो दिलीप 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 ଏଇଠି କଣ ଛୁଇଁଲେ କଲ୍ ଓଭର ଇଣ୍ଟରନେଟ ଅନମ୍ୟୁଟ ଟାକୁ ଛୁଇଁଲେ ମ୍ୟୁଟ ହେଲା କଲ୍ ମ୍ୟୁଟ କରି କିଛି ଶୁଭୁନି ଜିରୋ ହଁ ଶୁଭିଲା ହ୍ୟାଲୋ
ସମସ୍ତଙ୍କର ଏଇଟା ଆସୁଛି ଏଇଟା ହେମନ୍ତ କୁମାର ମିଶ୍ର।
ठीक सर ଆପଣ ବି ଯାହା କହିଲେ ଶୁଣିବେ।
Good morning, sir.
Good morning.
Congratulations for organizing such a nice seminar. Wish you success.
Okay, thank you. Thank you. Thank
I
you.
had been to your college 2-3 times for national seminar.
Okay, okay. Thank you.
Dr. Bairagi Panda was the HOD at that time.
Okay. Very warm good morning to all of you and all participants. Honorable Chief Patron of today's program, international webinar on recent developments in physics, and Honorable Principal of our college, RIHS Bhogarai, Balasore, India, Professor Sushil Kumar Giri, and our Honorable resource person from Iraq, Kolkata, and Bhubaneswar, Niger, Odisha. Now, I request our Honorable Principal to tell few words about the webinar. Thank you. Please, sir.
Good morning, one and all. I am very much pleased to know about this international webinar. Further, I am extremely delighted on having virtual presence of our beloved Chief Patron, Professor Dr. Madhumita Das, Vice Chancellor Fakir Mohan University, Odisha. Our invited speakers, Professor Ahmad J. Obed, Associate Professor Pratap Kumar Sahu, and Professor Samar Bagchi, who will certainly enlighten us on the topic recent development in physics. I welcome to all the guests and resource persons from the core of my heart, and on behalf of the Rural Institute of Higher Studies, Bhogarai, Balasore. Again, I welcome all the participants from India and abroad and expect full cooperation for this webinar with their valuable suggestion, rational interaction. I also welcome and convey my good wishes to the convener Tapan Kumar Panda, coordinator Mr. Dilip Kumar Jena, organizing secretary Mr. Dushmanta Kumar Das, moderator Mrs. Sheta Padmasini Patra, and their team for organizing this intellectual event with all their perseverance, hard work, honesty, and integrity. Last but not the least, I welcome to all the media friends, those who have also joined this educational event. Finally, I conclude my welcome address once again, wishing all the success. Thanking you all.
Thank you, Principal Sir of our institution, RHS Bhogarai. Now, I request Coordinator Mr. Dilip Kumar Jena, HOD of Physics of our institution, to give keynote address on this today's webinar.
Good morning, everybody. I must be obliged to our esteemed principal, Professor Sushil Kumar Giri, our chief patron, Professor Dr. Madhumita Das, Vice Chancellor, Fakir Mohan University, the honorable speakers, Professor Ahmad J. Obed, Professor Samar Bagchi, Associate Professor Pratap Kumar Sahu, for their support in this endeavor. It is a prime privilege on my part to provide keynote address on the topic of the webinar, Web Server Content Analysis and Description. Second topic is Photon Absorption and Band Gap Tuning. And third topic is low cost and no cost physics experiment for BSc students. So these are the topics to be discussed by the honorable speakers in today's webinar. So first topic is web server content analysis and description. The expansion of World Wide Web already has a huge impact on the way we carry out everyday life, both in private and at workplace. The available web-based data comes in a variety of formats and is mostly unstructured. Content analysis leads itself as the most appropriate method to analyze such data. Instead of investing a lot of time and energy in using more traditional methods for collecting data, such as interviews, surveys, and focus groups, a researcher can now just download data from the web without the need to engage with the users. This talk mainly involves the potential opportunities and challenges of applying content analysis to the web-based content. The second topic is photon absorption and band gap tuning. So this topic involves how to tune the bandwidth of photonic crystals for optoelectronic applications. The band gap can be tuned by the replacement of the functional group in the compound. So this new crystal has the maximum transparency in the entire visible region, and it exhibits nonlinear optical property. Last but interesting topic is low cost and no cost physics experiments for BSc students. This topic will inspire all physics loving people to go ahead in this direction. Once again, I welcome all of you to this August webinar. Let us enjoy the valuable talks of great speakers of today's webinar. Thank you. Mute ହେଇଛି ଶୁଣା ଯାଉଥିଲା ନା?
Thank you, sir. Now I request Professor Madhumita Das, Vice Chancellor of FM University, Chief Patron of this today's webinar, to say some few words about the highlights of these topics today. Thank you, madam.
Namaskar. Am I audible?
Yes, audible.
Visible also?
Yes, visible.
Okay. A very good morning to all of you. At the outset, I must congratulate the principal RIHS Bhograi, Mr. Sushil Kumar Giri, for inspiring and motivating all the faculty members for organizing a series of webinars in this college. So although everywhere we see that universities are organizing international and national webinars, but very few colleges are coming forward to organize this sort of webinar. So my heartiest congratulations goes to the principal and the entire team. And I must thank Dilip Kumar Jena, Dhirendra Kumar Jena, and all faculty members, all the young persons who are really motivated to take RIHS Bhograi in particular and in general Fakirmon University to a greater height. So on behalf of Fakirmon University, I welcome all the distinguished resource persons from Iraq, from Kolkata and from Niger for agreeing to deliver their addresses, because this is mainly, I think, for our young students and research scholars. They will be highly motivated to hear from you on the recent advances in physics. I learned that the topics will be covering web-based technology, photo absorption, and low-cost experiments in colleges. The last topic, the low-cost experiments, I think this will be very useful in particularly the colleges which are placed in remote places. So we can use these low-cost experiments, and then our students will be greatly benefited. But I'm going to talk a little bit about, I must tell you all the physicists who are available here in this, are connected to this webinar. When I was a student, my subject is geology. So when I was a student, usually we have a great debate or with my student friends. The physics students, they say that in science, always the first subject is physics. But I argue with them, no, geology comes first, then comes physics. So I have great respect for the subject physics. So I am extremely happy that you are organizing such an international webinar on physics. So I would like to tell that this present day is the day for research in or research with a multidisciplinary approach. So physics has gone to various fields like ICT, biology, and also medical science. So in medical science, how physics is used, I will just briefly tell you 1 or 2 minutes on that. The nuclear image processing has gone a long way in diagnosis and also the therapeutic process in the medical science. That is when we go for CT scan or PET scan or MRI. For X-ray, we use for CT scan, we use X-ray. For ultrasound, we use sound. And for also MRI, that is magnetic resonance imaging, we use magnetism, and also we use radioactive nuclides or pharmaceuticals for PET scan or the nuclear medicine. So when I talk about all these things, I think the advanced research in physics, it has gone to not only to all fields, but particularly the physicists play a great role in the science of nuclear imaging processes. And we also, I think when we are talking about physics or web-based technology, we are at the everything, whatever we know, we can know from the web science technology. We are connected. You can now see physically we are not connected, but we all are connected through this webinar by different links. So these are all advancement of physics combined with ICT, and now we are seeing or getting good results also in this pandemic COVID-19 situation. We can, by using technology, we can reach everyone and we can take science ahead well for the benefit of the society. So I think with this, I must again congratulate all of you. And this process of organizing webinars, I think you have also a plan to hold webinars, also a series of webinars. So for that also, I congratulate all of you. And this spirit also spread to other colleges, other affiliated colleges of Fakirman University. And I think RIHS has shown the path to other colleges in organizing this webinar. And I think with this, I wish a great success to this webinar. And thank you so much for inviting me and to be connected with you. Thank you. Namaskar.
Thank you, Mad. Thank you, ma'am. And your advice for giving the such a motivational speech to the other participants. I and our all participants of the institutions and outside the India also, all the participants are enthusiastic about that. You have told any thing about the research interest. Thanking you, ma'am. Now I request Professor Madhumita Das that she has already talked about the different fields of physics. Now I request our honorable resource person, Dr. Ahmad J. Obed, professor of University of Kufa, Iraq, who is a creative lecturer in the Department of Computer Science. He is an editor of Scopus Journal and also editor of MACT IOP Journal of Physics and guest editor in Key Engineering Material, Scopus Journal. He is also receivers in many Scopus Journal and reviewers of also many Scopus Journal. He is a leader of ICOTIS. Dr. Ahmed J. Obed also supervised several final projects of bachelor's and master's in his main line of work, and he is a frequent reviewer of international journal and international conferences. Sir, so we feel proud to have a virtual meeting with us. Hence, today, Professor J. Ahmad Obed enlighten us about their topic. That participants, please coordinate with him and listen about the new topic, which is web server content analysis and description. So please, sir, start now. Sir, am I audible?
Yes, sir.
Professor J. Ahmad from Iraq. Did you connected? Okay, then perhaps he is not connected. Then next I will tell our next resource person, Dr. Pratap Kumar Sahu. Sir, did you connected?
Yes, I'm connected. Yeah.
Okay. Then, sir, please you start. Then after that, we'll start the meeting of Professor Ahmad J. Obed.
Okay. Good morning, everybody. Sir, I have to share my screen. Yeah.
Okay.
Did you allow me to share?
Yes.
Okay. Let me check. No. Ajay, the host has to give me the enable the participation screen sharing. Then only I can do it.
Okay, you can do it.
Yeah. Please do it. Okay, then I will do it. Yeah.
Share screen.
The host. Who is the
Okay,
host?
okay. Now I am the host, but now I am sharing. You can share yourself also.
Okay. No, it is host disabled the participation screen sharing still.
Okay, okay, sir. Sir, please wait, sir.
Yeah. So, Tapan, what you have to do, you have to give me as a host again, because both two hosts can be possible. Okay, more than one host is possible. If you make me host, then it is possible that I can do it again. Okay. Yeah.
Professor Pratap Kumar Sahu. Okay, sir. Then first I will give you the chance to now. Professor J. Ahmad J. Obed came.
Oh, he's already there.
He is already there. So first I will give the chance to him. Then I will
No
give
problem.
the chance to
No
him.
problem.
Okay.
No problem. Go
Okay,
ahead.
sir. Professor Ahmad J. Obed, sir. Please, can you listen, sir?
Good morning, everyone.
Okay, sir. Thank you.
Good morning.
Okay.
Hello.
Yes.
Yeah, my voice is clear?
Yes, yes.
Thank you. Thank you. Hello.
Yes, sir. It is audible.
Okay, okay, okay.
Okay, sir. Please start.
Yes, yes. Just 1 second to open my seminar and try to open it. I will share my screen right now. You just confirm me if it is visible to everyone.
Yes. Yes.
Now it's visible.
Yes.
Hello.
Yes, sir. Visual.
Okay.
Audible, sir.
Okay. Good morning, everybody. Thank you for giving me this opportunity to present my seminar related to web server content analysis and description with in this workshop. So I am Dr. Ahmed J. Obaid from University of Kufa, Iraq. My field is web mining and web engineering analysis. I'm working on this field since 5 years ago. So shall I start my seminar, please?
Yes, sir. Yes, sir. Please start.
Okay. So today we will talking about the web server contents. At the beginning, we will go for the log file. It's the main parts or main content on server, and we will discuss some parameters and contents on the server itself. So at the beginning, let us understand what is the log files. What we are mean about the we are logging and content and define the log files contents. Actually, the log files is nothing but a registry log file, a registry file. Sorry. So this log files, what is doing, register each and every activity done by the user through browsing the internet or through navigate some internet locations and websites when he's sitting on the desktop. So actually here in the first slide, you can watch 3 different log files exist. Someone maybe would like to visit Google, then browsing about something, for example, education websites or maybe government websites. So this log file is responsible to register his content, that user contents, and fix it all the contents in the text file and storing that contents in the server side. So suppose this user would like to visit certain kinds of content, so we can understand that user would like to for example, visit sport content, for example, visit like government contents, downloading some books, browsing some journal websites, and anyway. So the log files can becomes in different styles. Why? Because actually the servers, web servers, provide by different companies. So for each company, provide different infrastructure, different tools. However, the log files can contain different contents, but all these files common in some parameters. So, for example, each log files can have more extra content, but all these files can share some, like let us say, fixed content. For example, IP address is a fixed content. The time is the fixed content, but some other web log files can include, for example, the name of the users and something like that. So let us see how many types we have in log files. Actually, the log files comes in 4 types. And the access log files. Hello.
Thank you so much.
Hello.
Continue, sir. Okay, sir, continue.
Sir, you are muted, sir. Ahmad, sir, you are muted.
Hello.
Ahmad, sir, you have,
Yes.
okay, it is now audible.
Okay. So the log files actually comes in some types. The first one is the access log files. That means this log files register all the access content, all the access activities for those people who working on their systems. Suppose those users may be working through the desktop, through tab, through laptop, through like some other tools, smartphones, and accessing some websites through the internet connection. So the second log files, the second types of log files is the error log file. What is the useful of this one? The useful of this log file is to monitor the performance of our servers. Suppose if the servers having some issues in the tools and some like infrastructure, we can monitor the error log file that and then we detect the error in that server. So it's giving the performance behaviors about the web server itself. We cannot find any important information about our users. So agent log file, actually these log files reside on this in the client side and the user side. Why? It's actually stored in the computer itself, and this log file register the activity of the user. For example, it's login in the system at 10 o'clock, it's leave on 11 o'clock. So for that reason, we cannot access these log files because of the privacy and the security of the user side. The fourth one is the referrer. That means provide only the information about the incomes of our users from where they are comes to this site, and it's not to provide the full information about users. Suppose, for example, the timestamp and IP address. So let us see some examples about these files. Here we can see the access is coming in this format, error income. This is the sample formats of our log files. When we are watching them, we can see their contents look like this table. So let us go for the next. Here the common parameters of log files. But which log files? This is the access log file. We are consider this one as the main part to understand our people behavior. So, for example, suppose this user typing some things in the browsers, web browser, Google or something, and he made some request to access some contents that exist in the web server. If that web server is a Google web server or some other servers. So then that server itself, what is doing, searching on his contents, then send the content to the user by response to him and showing that result in the web browsers. It's like this. So this process, it's our activity. We are using it daily, maybe 10, hundreds, thousands times per day. We are using this process. So what are the common parameters in this process? In all log files, I meant access log files. In all log files, we can find this contents as a common. So just give me 1 second to change my power supply. Sorry. So this is the common parameters. We are using it daily to understand our people's behavior. So the common parameters is the IP address. From IP address, I can detect the this is the actual IP address. So I can detect his location, his country, and all these things. Timestamp when that users comes and which time he's logging, and the request, what kinds of action he made. Actually, we did two requests in our activity. Either we are request some content, or maybe we are put some contents. For example, maybe I am request or maybe I am entered some information. Suppose here the login information for Google, Gmail, or maybe bank account. So we are actually we are given some information here. Status code is the like when we are browsing some contents, maybe according to that code, maybe we are not find that content. The page are or is not exist or those contents are not exist. So according to the status code, we are seeing that content or not, because some things may be wrong when we are typing something. So we got error message. So according to this, here we can understand the people's he's find his content or not, or maybe he faced some issues and he cannot watch that content at that time. And the bytes here, we are understood the people's how content are downloading or browsing in their like sessions. So either agent, that means this user, which browser he's using to access my contents in this server. And the request type, what he made, he get or post, either he put information or request information. This is the common parameters of the access log files. Here, the different formats also exist because different companies are actually providing this services. I mean, different companies providing web servers services, maybe for hosting information, maybe for providing some common information to be accessed by users. However, different formats comes according to the company and according to the web server settings or infrastructure. Here we can watch that all the log files comes with the common parameters who exist in the previous table or previous slide. So actually here we can understood what kinds of information we can extract it and what kinds of actions we can use. So for the access log files, actually all the records of the user can be registered or maybe can be detected by the server and storing in our systems. And the formats is look like this. Here we can watch that the day of is Wednesday in 2000, and that client with the IP address. This is not actual content because this is the sensitive information. No one can share the actual contents of log files. Why? Because of hackers, because of some fraud peoples can using this information and hack it all those users. So all the companies changing the exist information, the actual information, then put it for a research work. So here, what kinds of knowledge we can extract from this? Actually, we can extract the user profile. This very good services because some companies like Amazon, Foxy, and all those, they analyze the access log information to understand the behavior of their users. Maybe suppose someone from us browsing only sport information. So in the next sessions or in the next logins activity, this company provide me only the sport things. For example, sport shirts, sport wear, sport news, because they analyze my activity. They found me, I am interested in the sport content. So it's useful to understand the people's behavior from the activity. Also find the common groups. Maybe they put me in the in certain group that interest in the sport content. So according to this, some companies tries to develop their services, develop their like web infrastructure according to this. When I log in again in their systems after analyzing my activity, they put in the main screen all the sport contents. Why? Because they analyze my behavior, and maybe in that group or in that website, they they put me in the like committee that all them they are interested in sport, for example, in the sport things. So anyway, we can go for others. Here, frequent patterns also they understood through the access log files. My frequent content who accessed by me. For example, if I am visit fixed websites or fixed pages, they understood I am interested only on those contents. And the bandwidth usage, for example, some websites also given only small bandwidth for all the users, but if they found someone using huge bandwidth, they give interest to those people to why? To watch their movies, for example, to watch their products. So they give some interest to that user because he's browsing. So he's interested to like using our services. This is the perception from companies who using the log files to understand their pupils. So in the agent log file, agent is using the user browsers and browser versions. Why? Because this is in the user itself. It's not in the web server itself. And the error here, all the companies who providing this web server like services, providing the watching the server activity through this log file. Because if they want to know which web server having error in performance, they simply can watch this log files and find if that server working good or not, or having some issues in its work, then replacing it with some server. Referral log file here, browsing the information from the source when that user comes to me and visit my website or my content. So I can understand that people's using certain kinds of browsers or maybe using certain kinds of words to find my website. Then I improve the access information through develop some contents related to my websites. Then they able to find me easily than uh, old ways or old methods. Here we can see here so many companies provide log file analyzing. So log file analyzing tools, already these software providing some perceptions about only the statistics of users, about the users and their interest to in my websites. For example, let us see the AW State log analyzer. Here, I can summarize all these things, only provide statistics. How many users they enter to my website in, for example, today, in that hour, what kinds of content they are using, watching, for example, videos, photos, on all these things. What are the links are visited frequently? So I can like focus on that link itself. So so much companies providing these tools for their users, and some companies also put those tools in the web server itself for to understand. For example, this log files providing the geometric and map, because I can understand from which country they are visit my website. So let us go for others. Here we can watch, for example, the most hits content in my website, for example, images, and the bandwidth and the URL that used by users and the number of visited on that. here we can see that this page link is visited, for example, 12 times or viewed 12 times, but this one 4 times. So I can given interest on this. What is the content? Why this page or why this URL visited much time than this? So this is only statistics provided by log file analysis tools. So here also one example regarding the analysis content, uh, because according to this information, I can develop my website content or my server content. So actually there is some limitations in the web server analyzing tools. What are those limitations? Actually, log file do not indicate what information a user wants. It's only giving me the statistics. This page having more visits than this one, but actually they do not given me any perception about the user interest. I have to go for this statistics, then understood uh, uh, those contents by using some algorithms or maybe applying some models to understood my people's behavior. So for another one is the log file do not indicate what information users expected to find. Actually, they are browsing my content, but there is no expectation about their content, if they are reached the actual content or not. I have to go for their behaviors, then fine. Or maybe I have to put some feedback in their browsing content and to understood. So if we are looking to ourselves when browsing some content, there is some feedback, please vote us or please feedback us or giving some things to us. Why? Because so many companies would like to understand you yourself if you are happy with the browsing their contents or not. So some companies put some rating or voting window when you are browsing or enter to their websites. Log file cannot indicate whether that request fulfilled the user's need or not. So because the user actually enter to that content, and we do not know if he looking for another content or no, he will stop. Why? Because maybe he's browsing some other contents, or maybe he visiting some other companies. So how can I know? This is actually very big limitation to me. I have to use some developed models to understand those people. So they are happy with my company, or maybe happy with my browser, happy with my server or not. Log file did not indicate whether that information was easy to find or not. Why? Because I can watch that user access to these contents through some methods, but I don't know if he find my information or my content is easily or an easy way or hard way. Maybe he's logged into some pages to access these contents. Maybe he found that contents exactly within 1 second or 1 minute or 1 hour. I don't know. I have to analyze the log files, analyzing tools and contents. Then I understood these contents. Also, there is no indicate whether that information easy to use by the users or not. I don't know if that user using that information in easy way or not. So I have to go for some other techniques. Here we are applying some data mining techniques. Before we are going to this, why? Because we would like to make some knowledge extraction. So we have to go for example, classification. Classify that people's into certain classes. Suppose, for example, if they are terrorist people or maybe safe peoples, if they are looking to some contents are a fraud or maybe so I can classify my users according to their behavior. So I have to go for data mining techniques to understand, to providing those data to these techniques and then extract knowledge from my like users. Here, the data mining techniques actually can be divided into three parts. First one focus on the structure, the second on the content itself, and the third one is the usage. I am focused on the usage. Why? Because it's a concern with the server content or log file content analyzing. Here we are going to like extract the knowledge from log files by applying the data mining techniques and tools. After we are doing this, we are select the raw data and then processing, transforming it to into understandable form. Then select the data mining technique, which technique we would like to use. For example, suppose you would like to know what are the like users they, for example, sharing their or browsing some contents, or how I have to go for a clustering technique, or maybe I would like to classify those peoples into certain classes. For example, safe peoples, fraud peoples, for example, terrorist peoples. Actually, we are using classification inform like techniques, or maybe I would like to know those people's interest in the sport things, or those people's interest in, for example, in publication, or those people's browsing, for example, mobiles and all these things. So I have to go for and applying which techniques I have to use. It's according to my request. So here, actually, we are transforming the log files into understandable forms. Uh, Sorry, how can I remove these lines from screen? Is it possible? Hello?
Sir.
Actually, there is some lines in the screen when in my slides. I don't know how I how it comes and how can I remove those lines.
Okay. Sir. It is.
Tell him to stop share.
It is not possible, sir.
Okay.
Tell him.
So here, if we are go to this screen and watch these tables, we can understood that user one with the IP address this in the date of 21 October, in the time of 15, and the request of get, he visit this site, for example, with the browser of Mozilla. So,
Sir, please, sir.
yes.
You are having the stop share screen. Stop share. Then you can stop it.
Okay. I'm controlling it. No problem. Okay. Now it's visible.
Yes, visible.
Okay. Yes. So according to this, I can understand my peoples. They are, for example, this user visit this website or this user visit this website. So according to the transfer information, I can understand because this actually comes in the text. I have to concatenate these texts and separate the text by using some pre-processing tools and transforming it to the understandable table for this one, like this one. So after like making my data of log files into this table or in this form, I can easily apply some data mining techniques to provide me the certain kinds of knowledge extraction. So suppose we are going for this different analyzing. For suppose this one only count the statistics for auto. Actually, the analyzing tools do not providing this information for me. I have to analyze this those contents, then transforming it into these are tables. Here I am counting, so I can understand that this user one is interested in this website or in this link or in this page. Why I have to analyze this page and extract knowledge from this page, then concatenate this knowledge with that user. And also this one also. So I can grouping those users and this one also. I can grouping those users in the same group. For example, let us say those users interest in the, for example, mobile technology, or maybe some arts or sports or news, political contents. So I can separate them by using data mining techniques. So there are many techniques can use for extracting knowledge. For example, association rule or frequent pattern mining, classification, clustering. What kinds of techniques I want, I can apply in those tables. Here we are using different analyzing. This is actually done by user side, is not by the server side. The server cannot do like this. Only giving me statistics, then I have to register all this content, then transforming in the text, then applying some techniques to providing me like these tables. So for the user, I can hear weighting their behavior, for example, 0, 1, if he visit that page or not, if he visit that website or not, I can give him weight 1. Otherwise, if he's not visit others, I can give him weight 0. And that maybe sometimes I am using the fuzzy technique. For example, if he visit that website much than others, I can give him weight 0.9. If my was from 0 to 1, from my range. So it's up to my application I might be analyzing. Here is just example of using data mining techniques. Here we are using clustering information, clustering techniques to understand the behavior of my users. So here I can find that those users sharing the same behavior, sharing the same features. For example, those people focus on certain kinds of content. Those peoples also. So I can providing those peoples the same services. So these analyzing using by my using by so many companies to understand those peoples, to providing them better services, or maybe to let them find their contents in easy way, and all of these things. So according to these techniques, I can understand my behavior, my user behavior, and grouping them into coherency groups like this. So actually, according to us, also we have some limitations in our research work on in the web, like log files itself, the log file studies. What kinds of limitation we have? Actually, the first limitation is the types of algorithm you are used to analyze these contents. For example, we cannot use all algorithms or techniques to analyze these contents in correct way. We have to understand the content. Then we will find the possible algorithm or possible techniques to give us knowledge, best knowledge to understand. For example, suppose in the clustering, we cannot use all the clustering techniques. We have to choose which one is better to for this information to provide me a good knowledge, because it's depend on the my analyzing or my representation of those data into certain formats. actually the techniques to be, applied according to the data formats. So the second limitation also on the log files also there is so many features. I have to select the good features. What is the important features I have to choose, and what are the let us say less important features. For example, the IP address is the important features. I can understand my peoples according to their IP address, but for example, maybe the agent browsers, maybe it's not useful for me. I can give that feature, for example, out of 100, I can give 50 to this information, but for IP address, I can give 90. So it's up to me. I have to choose what, like the features, what are the important features for my studying. And this, also, there is one limitation also in the collect of these data. Actually, log files is very sensitive information. None of the company gives you this information free, and you can access those information uh, at any time you want. No, it's not possible. You have to go for those companies and apply some form. And when they are giving you this information or providing this information in the internet, they are changing so much contents. For example, the timestamp, the actual contents, and the IP address. Because why? Because of the privacy. I cannot use their actual contents, because simply you can log into my system if you are know my actual IP address and my browsers and my agent information. So you can access by me if you're having if you have a good knowledge about the hacking, and it's simply sensitive to others. So this is very big limitation, because the available data on the internet belong to 2000s, or maybe before 2000 years. So that's why 10 years or 15 years ago, or maybe 20 years ago, I cannot understand, or maybe I cannot understand by user behaviors. So for each company, do not share their actual contents, and using those contents only for their purposes. Do not provide these contents free to all users to applying their research works. And if some company do like that, actually it's changing their information, changing IP address, changing some links, or removing some links before providing this free of access. So another limitation also is to analyzing the segments of log files, because the log files records comes in the continuous strings. I have to segment these strings into good or and for example, like if that user visit if that user visit website, it comes in the long link. I have to understand that link, if it belongs to this website or belongs to this page, and all. And this is the common for other records, because I have to go for to separate that user ID, then timestamp, then type of request, then the status code. Actually, I have to apply some text mining techniques to separate that text into coherence portion or parts. So this is also challenge, because why? Because the log files comes in different formats. So I cannot apply fixed process to all log files. I have to adjust my tools according to the log file structure and format. So I am finished my presentation by
Okay.
analyzing
Okay, thank you.
some things about log files contents and information. I have all the users here, or sorry, all the visitors or attendants here. They got knowledge about log files and understood well what kinds of information they can extract from this content. Thank you for listening, and thank you for all of you. Thank you.
Okay, thank you, sir. Okay, thank you, sir,
You
for
is
your
welcome.
giving the about parameters of log files, users of browsers, common parameters of log files, and server log files patterns, about different company of using the log file. And you have given basic idea about that, and our participants also learn from this very much clearly. Then, sir, next our professor, Associate Professor Dr. Pratap Kumar Sahu of School of Physical Science, Niger, Bhubaneswar, Odisha, India, has research interest in nanophotonics, plasmonics, etc., and done PhD in physics in ion beam induced epitaxy of silicon and alpha quartz. He is a visiting student of University of Göttingen, Germany. He referees of many international journals like Physics B, Pramana Journal of Physics, and Journal of Nanomaterials. He published a book on ion beam induced epitaxial crystallization, and also invited as speakers in many international conferences. Today, Associate Professor Pratap Kumar Sahu will enlighten the participants about cooperation between photonic absorption and band gap tuning in wide band gap semiconductor. Please, sir.
Okay. Hello. Can you hear me?
Okay. Yes.
Yes. Okay. So now let me share my screen. Yeah. So can you see now?
Yes.
Okay. So shall I start?
Yes, sir.
Okay. Okay. Good morning, everybody. Thank you, Tapan, and the team for giving me this opportunity to talk about some of my research works. And yeah, it is pleasure that RIHS Bhograi is organizing such an international conference. Okay, thanks to the team for this their grand success in this webinar. So I hope most of you know about Niger. I will just brief it. Maybe some people may not know it. So Niger is a very young institute. It is only 12 years old. And we have started just 12 years old as a young faculty. Yeah, when I was just 30 years old. And now, yeah, so this is the beautiful building now. We have moved in 2015 only. And if you go to our academic section or research activities in our website, you will be able to know that how Niger is doing all over India and the world. Okay. And in the Department of Physics, we have a huge spread over of different areas. We have 28 faculties, we have 10 scientific staffs, 150 undergrad students, 80 PhD students. We have started the integrated MSc program. And let me brief that we have basically 3 different programs. One is called integrated MSc, where after 10+2, student has to appear our next exam, National Eligibility Test exam, which is on 29th of September this year due to this pandemic. Normally it happens in last week of June. And those qualify this exam, next exam, they join as an integrated MSc student, and those students get a scholarship of 5,000 rupees from the beginning. All the students get the scholarship, and they do 5-year MSc program, 2-year BSc, and then 5 years. But there is no exit policy after BSc; they cannot move. Okay, but after 5 years, they have a lot of opportunities. in between, in the summer, they used to go abroad and do all different good institutions in India do their summer projects. And we have large number of facilities. I'll show some of them that to do the international level research. Then those MSc students, at least I know in our department of physics, at least 50% of the students publish an international journal publication before they leave in their MSc program to go to PhD or going outside or abroad for higher studies. Then we have PhD program. After then we have integrated PhD program, like after 10+2, even if after BSc or after BTech, we have, if they qualify JEST, NET or JAM exam, then they can appear our interview directly. And if they qualify the interview, they join as integrated PhD students. Integrated PhD students normally do 2-year MSc in our program, and then they started their PhD. So basically, they save 2 years. Like PhD, normally they take 5 years, whereas in 6 years they finish MSc and PhD. So this is a good program, and from the beginning also they get a scholarship of 25,000 for past 2 years in MSc, and then join as a PhD, regular PhD scholarship. And those who come after MSc, then they do the standard PhD program. So we have our own written test after NET, GATE and CSI. Those who qualify our written, they go to interview and then they join as a PhD students. So these are the standard education system in Niger. And in the Department of Physics, we have basically 5 different groups. One is theory and experiment of high energy physics. There's 2 groups, and theory and experimental condensed matter physics. There are 2 groups, and cosmology is another area. So then, if you have seen that in experimental condensed matter physics, we have doing ion beam physics, ion matter interaction. We have a small accelerator called 400 to 800 kV ion implanter. Then we have do nanopatterning, we do super magnetism and exchange interactions, we do superconductivity, ultra cool atoms, nonlinear optics, all these kind of different areas people work. So basically 5 different areas, 5 faculty are leading, okay, 5 different groups. Then we have a high energy experimental groups. They do the experiment at LHC in Switzerland, ALICE in Switzerland, CERN or IBM lab in US. And after doing their experiment, they come here and back and do the results and data analysis. And then the theoretical group is also a large number of groups. Some people are doing quantum QCD, string theory and astrophysics kind of things, and other physics people do the condensed matter, like electronic structure, DFT calculations, quantum computations, qubit computations, many-body theory, or weak or strong correlated systems. So these are very different areas of physics people work. So coming down my research work, we work on basically nanomaterials, and we have most of the facilities available. We do the fabrication ourselves using interference lithography and implantation, thin films, copolymer lithography. Then we characterize, like we have our FESEM, scanning electron microscopy, we have transmission electron microscopy, we have all kind of photoluminescence, electroluminescence, cathodoluminescence. For nonlinear optics, we have JESCAN technique. For magnetic property, we have MOOC, SQUID. So all semiconducting, magnetic and metallic properties we can study of the materials for different kind of applications like anti-reflections, quantum dot arrays, surface Lajon, polarity, and all nonlinear dynamics and quantum magnetic recording. So yes, all and I focused on basically ion implantations, that is electronic and energy loss processes in the recrystallization. Like if like I throw a ball, so what will happen? I throw a ball, let us say soft wall. The wall is not very hard and it is soft wall. So the ball will go inside a little bit. Some of the particle from the wall will come out. Okay, so those particles are coming out. It's called sputtering, sputtered particles. And after certain time, because the ball is going with a kinetic energy, and when this kinetic energy touches the surface, as you go in and in, it loses energy. When it loses energy, that we call the energy loss. And this energy loss, then after a certain time, it stops there. It cannot go beyond because its kinetic energy becomes zero. Okay. Then similarly, if I have an ion, energetic ion like 100 keV, 200 keV, 100 MeV, so starting from few keV to hundreds of MeV, any energy you can use, and this energetic ions will go into the materials. In this material, what will happen that since an atom is energetic particles, so in the matter it will go in, and when it go in, it will lose energy in two ways. One is called electronic energy loss, another is called nuclear energy loss. When we call a nuclear energy loss, it interacts with the atom as a whole. Then what will happen? That atom as a whole means it displaces the atom. It is like elastic scattering. Then an atom becomes disturbed. Okay, then defect creates. And then I will talk about you how the defects are useful for us. Sometimes we said, okay, we need a perfection, but some defects also help us to improve. Okay, that's the things, all the semiconductor industry depends on the defects. Okay, so this is how the electronic and nuclear energy loss happens. But in electronic energy loss is another process. Like if I have a very high speed car is going, you are just standing just nearby to the road. Then what will happen? You feel that some wind comes and disturb you and go. Then after a certain time, you feel, okay, again stable. But for a moment, you feel that you shake yourself. Similarly, when the energetic ion will very high energy or swift heavy ion we call it, like hundreds of MeV ion will go, then it don't have time to interact with the atom as a whole. It interacts with the electrons cloud of the atom. Then when it interacts with the electron cloud, then it's going. Then electron cloud, when it interact and go, then electrons, and then it make a vibration in the lattice. And this lattice vibration basically called phonons. And when this phonon interact with this electron, then it is called electron-phonon coupling. And when this electron-phonon coupling are electron-phonon together, okay, that is basically called a kind of excitance. And this excitant move, then it creates a lot of heat. If you calculate in a picosecond range or into interval 12 seconds, okay, in that small time, the temperature go to 5,000 degrees centigrade, 3,000 degrees centigrade inside the lattice. So that high temperature create a lot of different kind of phenomena inside the matrix, okay, or inside the sample. And these create, and it suddenly suddenly cool down, because for few seconds, 10 to 12 seconds, it goes very, very high, then it cool down. Then this quenching process makes nanoparticles, sometimes make ion tracks, sometimes take different kind of properties like completely distorted structures, extended defects. All these things can happen. Okay. So somebody is hello. Somebody is tapping my screen or what?
No, sir. Please, you can stop sharing in the screen. Share screen, you stop it. Then it will.
Okay, stop share. Okay.
Sir, stop sharing screen. Share screen, you stop it, then it will. Okay.
Okay, let me do again. No, somebody is tapping. I cannot do even if sharing now. Okay. No, I can't share now. I don't know why.
You can do it, sir. You are co-host, so you can do it.
No, that I understand. You have given me well, yes, everything is working. Let me check why I cannot share. Okay, sorry. This is working. My mic is working.
Okay,
And,
working.
But I cannot share the screen. Can I do one thing? I just leave for a moment, then come back. Okay. Hello.
For a moment, leave for a moment means, sir.
Means I'll
Okay.
I'll go away because I'm not able to share the screen. If somebody got permission and he's tampering locked my screen, so I cannot do anything in my screen itself.
Okay. Okay, sir.
So sorry for this thing. Oh, shit. I cannot leave also. I don't know what happens.
Sir, your mobile becomes hang, sir. Mobile or computer become hang.
In my computer, I'm sitting in my computer.
Okay, computer, sir, some problem is there, I think.
Because I can't do anything.
Sir, please carry on, sir. Please carry on. No problem. Carry on.
Carry on, sir. Carry on. Without slide, you can carry on, sir.
Okay. Without slide. Okay.
Okay, you can carry on, sir, without slide.
Okay. So, yeah. So I hope. I don't know.
Can I remove you again? You will come.
Yes, that's true. That will be the best thing to come. Yeah.
Okay.
Because I cannot leave myself. Yeah.
Okay. I will remove you. Then you will come again.
Yeah. That will be the best thing. Because I cannot leave myself. It happens like that way.
Okay, sir. Then you can start same way without slide.
I can start.
Yes, sir. You can start.
Okay. By the time I am trying in the other way. Okay. Yeah. So if those who have seen this slide, so this is like a process we work on nuclear energy loss and electronic energy loss, and in this process, what we are doing, like so we create different kind of defects, okay, in the matrix, and these defects are useful for many different applications, like our semiconductor industry, like our optoelectronic industry, and that is one kind of applications. So then we work on like UV visible or infrared anti-reflection coatings or anti-reflection layers. So what we do, instead of that for the glasses we are using, okay, and for some in the sunglass we put one kind of layer, or if I have anti-reflection we use another kind of layer. So this is a different kind of layer we use for different purposes, but we have a technique where we don't need this layer at all. So what we do, we do some kind of nano layers, nano structuring on the surface itself without putting in layers. So and the structure becomes such that the refractive index of that structures exactly matches with the thin film I need for that particular applications. So those kind of fabrication we do, and we have a industry in Switzerland where they have taken this as a patent, and they produce that kind of lenses for these different kind of sunglasses or nuclear.
Sir, now you try to share your screen.
Let us see. No, it's not really working.
Okay, then leave it, sir.
Okay, I'm sorry for these disturbances. Okay, happens.
Okay.
And I think, I don't know, something is locked so that I cannot move my slide. I cannot do anything on my screen itself. Okay, except I can speak and I cannot do anything on my screen. Okay. Yeah. So then these are the few applications we work on. Then another application, like we do different kind of gratings, that is for UV or visible optics for polarizations. Okay. Then we work for these biosensors, gas sensors, and gas sensors, all these things. Sorry, it's not getting even if sometimes difficult. What happens actually? I don't know. Oh, is it okay now?
Okay, sir.
Yes, sir.
Can you see now?
Yes.
Okay.
Yes, sir. Okay.
Okay. Yeah. Sorry. I can come back again. Yeah. So then I'll talk about a few new things we are doing nowadays. Okay. Before going to the main topic, how the photon observes. Okay. And that works in the nonlinear optics. And I'll explain what the nonlinear optics is, so that the higher level students like BSc or MSc level students will be able to understand something. Okay. Yeah. So this is one kind of special kind of materials which is called NiBi3 or NiBi. So this system is a very interesting system because it shows coexistence of superconductivity and ferromagnetism. So you know, superconductivity and ferromagnetism cannot stay together. Why? Because when you need a ferromagnet, then what will happen? If you apply a magnetic field, all the spins will be aligned and there is a net magnetization you get. And that means if you apply a magnetic field, then it is Zeeman split. And this Zeeman splitting happens when all the spins are aligned. Then you get a ferromagnetism. But in case of a superconductivity, what you do when you apply a field or you apply some electrical signal, then the Cooper pair forms. And at certain temperature, then the resistance, the conductivity becomes so high, and the Cooper pairs and the resistance will go down, 0. Then we call it superconductivity. In that case, that means it don't like the ferromagnetism. But there are some materials, and the geometry is such, like the geometry I have shown in the left side, that it will show both superconductivity and ferromagnetism together. So what is happening, and another very interesting aspect happens in these areas. So what we take a substrate like silicon or silicon oxide, then deposit its bismuth. Then what will happen that then on the bismuth, the surface you look, that SEM image looks very, very smooth. Then we put some nickel on it. And what will happen when the nickel goes, there is a self-diffusion happens because the coefficient of bismuth in nickel is very, very high. Okay, the diffusion coefficient. So it is diffused so far in itself, in doing the thin film itself, it make and form a particular phase called NiBi3. And then when NiBi3 phase forms, then this particular materials is coexistence, shows the coexistence of superconducting and ferromagnetic. Then at the same time, if you see the surface looks something like this. In the right hand side you can see. Okay. Then we are wondering why this kind of structures come in. So try to get some information or get the logic behind it. So the basic is like this. That effect is basically called Turing effect. What do you mean by Turing effect? There is a scientist and computer science engineer, which is basically in the University of Cambridge. He discovered that if we have an innovator and fast diffuser, right? One is called an innovator and it is called acceptor. Okay, and A and I. Then if something is very, very fast diffuser in a material, then what will happen? The diffusion coefficient goes like a second order differential equation. The diffusion normal reaction happens if you know the Fick's law that the diffusion coefficient is proportional to the d times A, but it goes to the second order, d square A by dt dx square. And if you go to the second order, then what will happen? Then, as you know, if I have a matrix, if I have equation, I take a derivative of it. What I will get? I get the maxima and minima. And in the maxima and minima, the intensity becomes very, very high. Okay, either in the maxima point or in the minimum point. That means in some places the intensity will be very, very high. In some places, intensity will be 0. And that's why such kind of pattern can be generated. Okay, this kind of pattern you can generate. In the left corner side image, you can see. This is the region in biological sample, like you are doing tattoo. And on your skin, the tattoo remains for a long, long time. Okay, similarly, the cheetah got such kind of structures because some particular element of magnesium is diffused to its skin so that it got this kind of structures. The jellyfish, the giraffe, the snails, all this kind of surface in nature you found because of this mechanism. That is called reaction diffusion mechanism. Okay, that's why in our sample, we see some kind of magnetic lines of forces. Like nickel is a magnet, and if I put a small ferromagnet, if I have a small magnet, put the iron dust particles, then it will create lines of force around it. Similarly, since our nickel and NiBi3 system is there, and then you will find that all the bismuth will go to all the nickel particle will go to around this bismuth NiBi3 systems. So it make a kind of structures which is almost kind of a snare structures. So all these natural mechanism, natural natures, you see that kind of structures. Okay, yeah, and then basically that is sometimes we call this fractal structures, and all these fractal structures are coming. Natural factors are coming from this kind of mechanism called understanding the physics behind it. Okay, so then I come to another world called silicon world. And everybody know that how important is silicon. All your chips in your mobile, in your computer, in your laptop, all the electronics technique need a chip, and that chip is silicon chips. And silicon is most abundant semiconductors. Everything is understood, is well-studied materials, but still, if you see, it is not suitable for optoelectronics. What do you mean by optoelectronics? This is transparent material you need, which work as electronic materials also. So it is not transparent. Or it has not the property that it can show that where the optoelectronics material like quartz and other things can show. Can we make this? If we make this, this is a challenge to the world that then all same thing we can do in using the silicon what the optoelectronic industry can do. So the silicon can be replaced with optoelectronics as well as normal semiconductor industry. Okay, so that's why there is a challenge, and we take some of the things to verify that whether it can be used as a laser, because laser, you know that different people are using in different materials, whether silicon can be used as a semiconductor laser. So that's why what we do, this right hand picture, if you see, I implant some ions. Like I explained in the beginning, if I implant some ions, then it will go inside and stay. Then whatever you do, if this structure will remain, because it will not go away, because it's already inside the matrix, inside the samples. Then what will happen? If you see, if I take a photoluminescence, okay, that means if I put the excite with light, then some other color is coming off. The color is coming off is basically the photoluminescence. And this color, if I see, is basically, you will find for the silicon the band gap is 0.7 eV or sometimes 1.1 eV, and only 1.1 eV. Can I make it higher? If I can make it higher, then only it can be used for optoelectronics or the lasing applications. Otherwise, it can simply use as a UV, okay, emitter. So these are some kind of things. Then how it happens? Because I'll explain that how it happens actually. Okay, this happens due to the phonon assistance. How do we mean by phonons? You know. So just one slide for the students to understand that the phonon and electron are stay in two different worlds. Okay, what do you mean by that? Electrons, everybody you know. Yeah, if I have an atom and it has a electron cloud, and if there are different cells, and in outermost there is some electrons, either free or bound. Okay, and these electrons live in the bands. Okay, either in the ground state or in the excited state. Okay, it has a potential, ionic potential, depending on whether you can give the energy to take out of the electrons or give more energy to add in the electrons. Then you can make an ion positive or negative. Okay, you can make gold plus or gold minus. You can make carbon plus, you can make carbon minus. Okay, then if you can, yeah. So similarly, then this is the called electronic states. But similarly, there is something called phonons. Okay, like phonons are the quantized ionic vibration on the potential generated by the electrons. So what do we mean by that? In the matrix, if I have a assume, and those who are in the BSc or MSc, they have learned the Drude model. Okay, that I have a crystal matrix. In this crystal, there's a vibration, crystal vibration. Okay, then crystal vibration happens due to phonons. That is, like a photon is my carrier of light. Okay, light intensity or light. Then that is a quantum of light particle. Like a phonons is the quantum of thermal energy. Okay, that means if in a lattice there is a vibration of phonons, phonon modes are there. That means if I have a phonon like photons, then this is the carrier of thermal energy. When it moves due to the ionic vibrations, then the thermal energy goes from one place to another place. That's why it is heating up. Okay, yeah, process. So this, if when the electron in the vibration happens due to what? Because of the electronic state also. What will happen if I put a light? The electrons will start moving around or start arranging themselves in a different ways, depending on what kind of material you are taking. Okay, then these vibrations, when create some thermal energy, then this try to move in a matrix, crystal matrix. Then when this electron and phonon interact, phonon.
না ওটা তো এর পরে ইয়ে আসবে আমি যার জন্য বলেছি আমি কিন্তু এটা শুনবো না আমি
then this electron phonon are produced, and this can be radiative, this can be non-radiative. This is valid for metallic system, this is valid for semiconducting systems. So then how it really works? Okay, in the next slide, like when I call a direct band gap and when I call it indirect band gap, like silicon, it is indirect band gap, and this is called EG. Right hand side you see, this is EG. Or if it is a direct band gap, if I have a valence band, then I have a conduction band. If I give some light or some energy H nu, then it excites an electron from the valence band to the conduction band. Then it cannot stay in the conduction band for longer after certain time, because it is always excited. You cannot stay always in the excited side. When you are angry, you are certainly sometimes angry, then you cool down. Okay, similarly in our electronic world, all the electrons cannot stay in the excited state always. They have to come down to the valence states. Okay, ground state. Then when they come down, they radiate some energy. Okay, that energy radiation is come out as omega PL. That is a band gap, and that band gap energy is called excitonic band gap. Okay, near band emission. Then you get a light output, and that light output is basically emission bands. Okay, that's called photoluminescence. But in some cases, there is indirect band gap, because this valence band and conduction band don't stay in the same energy level. It stays in the somewhere else. Okay, in the right hand side. And then all these electronic things, that when the electron will go up, that it cannot it has not enough energy to go up to that level because all the electrons C are staying in this conduction band, not the direct one. Then in that case, what will happen? If it will de-excite, okay, when it relax, it comes this Eg only. Then this much is the balance, now the band gap. Now the band gap, you see, it's supposed to be this much, okay, this much, but now it is this much small. That's why the band gap is smaller in indirect band gaps. So the thing is, can we make this Eg to the same like Eg? How do we do that? Okay. Then in the next slide, I will explain that. You see in the left side, okay, Eg is my band gap, that is 1 eV or 1.1 eV for the silicon. Then if I put some sufficient light energy, let us higher energy, then what will happen? Due to this electronic excitations, some holes are created. Either hole, then electron hole, or that is or phonons can be together. Then when the electron and phonon become together and it moves as a single particle, now this is called excitons. When this excitons comes, then excitons are free to move any k space. If you, as a physics student, I hope you understand what is my k space and what is the, this is virtual space or in the real space. In this virtual space, in the k space, if you see, I have a L point, gamma point, and X point, if you understand the semiconductor physics, or yeah, then this electron itself can move only in the valence band to conduction band. But when it becomes an exciton electron hole pair, this pair can move anywhere. Now it has higher energy. Okay, it can move to any state to any state. In that case, it can move from L this one to L of that one. So now this gap becomes E1, and E1 gap is 3 eV instead of 1 eV. So now the same matrix, if we can excite with a higher energy and with some special arrangement, like this can happen when I have a small nanoparticle. Then when the nanoparticle becomes small, it needs lower energy to excite the same process. Okay, that way we can say that electron hole pairs can help us to make a higher band gap. This is basically one concept is called quantum confinement model or zero-dimensional space. Then what is happening? Like this is another explanation. Like if I want to make this 3.3 eV instead of 1 eV, then what will happen? I have to make a quantum confinement model. That means we need C by D. Either it is a zero-dimensional space or C by D. C is the concentration of the nanoparticles. D is my diameter of the nanoparticles. Okay, then how many nanoparticles are having a zero dimension? When we call a zero dimension means I have a dot. It don't have X, Y, Z. Okay, it has not high bigger. It is a very small one. When one small sphere nanoparticle. Okay, so then the dimension is very, very small. Then we call it a nano, means it is in the within the de Broglie wavelength. Okay, of that. Then if the particle will be very, very small, it is like I have a small energetic particle in a huge background. Okay, then huge background is named potential well. So in quantum mechanics, we call it a potential well. That means I have a very large well, infinite well, and in this infinite well, I have a small energetic particles moving. Okay, then if we calculate this and do all these quantum mechanics calculations, then we will know that what is the vibration levels. Okay, what is the energy levels of different bands. Then from this energy level, we'll be able to know that what can be the band gap, how much band gap can be calculated. I hope those who are doing MSc and studying that quantum mechanics and this solid state physics, they understand how the band gap is calculated from that. Okay, so this is how we can make silicon and make a higher band gap structures like 3 electron volts. Okay, that means when the light is absorbed, that much energy will be used to excite the electron hole pair that make my band gap wider as compared to a small band gap of 1.1 eV to 3 eV. Okay, some of the this is the concept I'm telling in the simple sense. Okay, not going much deeper to the physics because many non-physics people might be there in the audience. Okay, then what do? We use a heavy ion energy of 100 MeV. That is called swift heavy ions. Okay, 50 MeV of gold I have used. I take a silicon matrix, 50 mm of gold I implant. Then it creates some kind of defects. And xenon, okay, then how many defects are there? As you go to higher and higher temperature around 350 degrees centigrade, the defects is come down. So I can control how many defects I have created. Okay, from that, due to this, in the beginning I told that if my energy, the shift heavy ions are very, very high, it has electronic energy loss. Inelastic scattering happens. Due to this electronic energy loss process, what will happen? The small nanoparticles are formed because it goes to very, very high temperature of 3000 degrees centigrade and suddenly quenches down. Due to this quenching effect, there is some kind of nanoparticles forms. If I do a transmission electron microscopy and I see inside of nanoparticles of 3 nanometer order image, then you see these are the crystals. All are amorphous silicon and these are crystalline silicon. Now, these are nanoparticles inside a seed. Okay, these are quantum confinement effects. Quantum particle is confined in an infinite wall, infinite potential. And the particle size is nearly 5 nanometer, average particle size. So these nanoparticles are emitters, light emitter at higher energy. Okay, that's why I can make the silicon from 1 eV to 3 eV. So this is 3.25 eV light, you see. This is the PL spectra, photoluminescence spectra. From this photoluminescence spectra, I will be able to see that how the 3.2 eV nanoparticle will coming out. Nanoparticle give the 3.2 eV light output. Okay, so this is how we can make a silicon nanoparticle, okay, and we can get a higher band gap materials. Okay, make it higher band gap. So now this is the indirect band gap structures. Now you know already direct band gap structures. So zinc oxide or wide band gap semiconductors are like that. They are a direct band gap. So zinc oxide band gap is 3.2 eV. And I know that if I have used the defects, here I am trying to use my defect because all the semiconductors you use. Okay. Somebody again scratching the screen. Okay. So it is not done by me. Somebody has access, I ask. That's thank you. Thank you. You have removed. Yeah. Okay, so now you see this is the application of defects. If I have defects in gallium nitride, zinc defects, then I can get a blue LED, which changed the world, got the Nobel Prize due to the blue LED. Once the blue LED is developed, then we can get all kind of LED lights. All the world now changed to the LED. Before it was a fluorescence. Okay, phosphorescence lights. Okay, you have a CFL balls. Now CFL ball has gone. Everything is gone. Everything is transferred to the LEDs. All your home are using LED lights. All the electronic industry now on the TV LED screens. Okay, mobile is LED screen, not this capacitive screen. Okay, everything is changes to LEDs. So this is due to the discovery of blue LEDs. Okay, in 4 years and 6 years back, we got the Nobel Prize. This Wakama and these 3 people got Nobel Prize in for blue LED development. Then, if you have a luminescence amorphous silicon, you see the amorphous silicon can be red light, which is in the visible range. Okay, normally silicon is supposed to give the 1.1 eV, which is the UV light. You cannot see it. Okay, but now you have all colors you can get. Okay, the first transistor you have seen so big. Now all the transistors are very, very small. Okay, that's why you will able to see. You can use your watch as a mobile. Okay, you can get the message. You can call from the watch. You can put your scene in the watch. So small things can be used. Okay, everything, all the semiconductor industry development is happening due to the use of defects. Okay, yeah. So then I already explained that what are the application of this electron phonons coupling, interaction between electron and phonons. Due to this interaction of electron phonons, you see there's some kind of balls. These are zinc oxide balls. They show blue light. Okay, so this can be used. But zinc oxide till now has an N-type material. The band gap can be tuned from 2.8 to 4 eV. Okay, but you can tune anything within that. But very challenging is zinc oxide to make it P-type. So recently, there are some works people have started. If we can create oxygen defects, okay, defects in oxygen defects, then we can make it P-type. So if I have a P-type, and N-type zinc oxide, I can make a PN junction, which is used in the semiconductor. PN junction or PNP transistors. Given most of the cases, you need transistors and PN junction diodes, okay, along with your capacitor and emitter to make all these semiconductors. These are the basic building block of semiconductors. Okay, so what we do? Okay, we study something different. That different is like phonon tunneling. Okay, like you might have seen that electron tunneling. Okay, that STM, they got Nobel Prize. Okay, similarly, this is a phonon tunneling. What happens that in electrons, like in your diodes, you should have sufficient energy of these depletion layers. If you cross the energy of these depletion layers, okay, hello.
Okay, sir.
Yeah, sorry. Again, the similar thing happens. Can you see it again?
Yes, we are able to see.
You are able to see my screen?
Yes.
Okay, thank you. Yeah. So then, this is a phonon tunnel device I called. In this phonon tunnel device, what will happen? Like the depletion layer has to be crossed that potential so that a PN junction or diode can work. Similarly, if I have a crystalline matrix like a zinc oxide, I can create a small barrier layer, and in this barrier layer, what will happen that I can, if I excite with something, then the phonon can transport that barrier and go up. If some barrier can be moved, then we call it a tunnel. If the tunnel, that means energy is necessary to go through that tunnel, that from this end to that end it can go. Similarly, if we can create by ion implantation that a oxygen-rich area, pure zinc oxide and oxygen-rich area, then it will become a PNP transistor. If I put a light that can use as a phonon tunnel device, like you can think of an example or application of phonon tunnel. Now you have the fiber optics. If I have a fiber optics line, in this room has a light, enough light, other room has no light. If I have a fiber optics going through this, okay, telecommunication is another world, okay, but in normal light I am talking that you can see that the other room can be lighted using the fiber optics, okay, from this room to that room. Light can go from this room to that room like a wall. Similarly, if I can make something phonon using the phonon optic fiber optics, then what will happen? The temperature, that means thermal energy, can go from one room to another. That means if this room has a AC having 22 degrees centigrade, I can, without putting the AC in the other room, I can take these phonon tunnels, devices, phonon fiber optics, then other room becomes colder. So you will see in another 5 years the same thing. Now the light is going like in fiber optics. In 5 years, you will see that people are working on it. Now in 5 years time, you people will see that how the thermal energy can be taken from one room to another. Using one AC room, I can make other room also AC. Okay, without putting an AC. So this is what kind of science is developed. Then, okay, then similarly, this PNP transistor you can make, okay, diodes you can make, all these things you can make. Then how do we characterize it? You take a single nanorod of zinc oxide like this, okay? This is a zinc oxide. Then from this, I know the concentration of the oxygen I am putting. If the concentration is higher, this is a P-type. If the concentration is lower, it's N-type. So I can distinguish between P-type and N-type. So a single nanorod can be a P-type and N-type. I can make a diode or device like that. Okay. Then I know from the surface how it looks. Then I scan with the conducting AFM, atomic force microscopy. And then I do this IB characteristic. From the IB characteristics, look like a PN junction, properties of a PN junction. Okay, so from there I can make a PNP transistor, okay, or a PN transistor of a single nanowire. And nanowire diameter is how much? 500 nanometer. Length is 2 micrometer. Very small. Those things can be used, normally used in our miniaturization devices, in our mobiles, okay, in our watches, okay, all these things. You know this characteristic from the beginning, basic understanding, then you apply for this. Okay. So with this, I come to this nonlinear optics part. So Tapan, how much time I can speak now? Hello?
Yes, sir. Within 5 minutes.
Okay, 5 minutes I'll summarize. Okay. Yeah. Thank you for giving 5 minutes. Yeah. Yeah. Okay. So then we have to understand the nonlinear optics. So this has also a huge application. Okay. This has, you can storage the optical data. You have a optical switch, like on your screen. You have a touch screen profiling. All these things you can do. Okay. Then from where this nonlinearity comes? Okay. When it is called a linear, because if F is proportional to N, F is equal to M times A. Okay, that means force is proportional to the acceleration. Okay, then we call it a linear equation. Okay, F is equal to Ma is a linear equation. But in some cases, if it goes as a square, it goes as a cube, then it is no more linear. Then we call it a non-linear. Okay, similarly, in optics, if I get the polarization, in optics, what will happen? If I have an atom, polarized atom, then it has a positive and negative dipoles. And when this dipole get energy, then it has different energetic modes. Okay, and it's the susceptibility goes in. If I expand this susceptibility, you go that epsilon naught into chi times E. Okay, chi square into E square, chi q into EQ. Then first term is my linear term. Second term is square. Okay, third term, second order effects. Third term is third order effects. So nonlinear optics comes from second order, third order. So most of the cases, second order is very, very small. So we suppressed it. Most of the cases is the third order nonlinear dynamics or third order nonlinear optics. Okay. So nonlinear optics is coming like harmonic generators, four-wave mixing. All these are a concept of this. Then I use particularly two concepts that is called two-photon absorption or saturable absorption. What happens if I take this zinc oxide matrix where I have the defects? Okay, I create a single nanorod of zinc oxide. These are used as nonlinear optics. This can be used for different applications of these nonlinear processes. Okay, so this is coming from the two-photon absorption is the origin coming from the Maria Goeppert-Mayer. He got the Nobel Prize for this in 1963 in the physics. What happens actually? The concept is here. Okay, I have the ground state and the excited state. But now I need the energy of this band gap. Then only the electron can be excited from ground state to excited state. Then when you come down or de-excite, light will come out. But let us say I don't have that much energy. What shall I do? Okay, so there's a concept. If I can match the exactly half of this band gap. I have the energy Eg by 2. Then if it 2 photon, this is 1 photon give that much energy, you will get an excitation. But now I have the photons with half of energy, exactly half of the energy. Then 2 photon can go to a virtual state. 1 photon will go to this virtual state, and then this virtual state to another virtual state, another photon. They will combine, and now they will give the same excitations. That means instead of 1 photon, 2 photon is absorbed to get the same excitation, the excitation. Okay. If you calculate the virtual time, okay, is let us E photon is less than 1 electron volt, okay, then if my arriving time is 100 octosecond, 10 to the minus 15 second, then if I go, you know the uncertainty principle of energy and time. Del E into del T is equal to expressed by 2. So now del T is T virtual. Del E is my energy gap. Del E into del T is expressed by 2. This is, yeah. So if this uncertainty principle you use, then how much time you need? The time is in octosecond, 10 to the minus 15 second. That means if I have a pulse wavelength of that much pulse width, that much small time, then the energy gap will be exactly half, and if 2 photon can be absorbed within that much time scale, and the same energy light output can get. So the concept is more little clear here. You see, I have only, if I have a continuous wavelength laser, then I continuously come in, then I need that much energy exactly go from ground state to excited state. But if I have a femtosecond laser, Each femtosecond laser is 100 femtoseconds, and in this femtosecond, I can calculate what is the power average. Then I give 2 photons is observed, then the light will come out. Okay, this is how the 2 photon absorption happens, and these are the typical experiments. Okay, then this is called a jet scan technique. One technique is called jet scan technique. These are basically different component of this jet scan technique. I have a sample here. I can move the sample like this. Okay, you see, this has to go to the central point, focus point. If it is going from central point to this, then it will go and get a minima. Similarly, this process is basically called the open aperture setting, because aperture is very, very large. If aperture is very, very small, okay. Yeah.
Okay, sir, start.
Yeah, yes. If the aperture is very small, you get the peak in the other direction. Similarly, you can get in the negative sides, and you can get in the positive side. So depending on what kind of configuration you are keeping, you can have 2 photon absorption or saturable absorption. Then I take a zinc oxide nanorods. These are small zinc oxide nanorods, like I showed the cartoon in the beginning. Each nanorod I have characterized whether it is zinc oxide or not. Then I don't make a defect with the cobalt ions. Okay, this is a cobalt dot. Then I want to study that what kind of stress is developed due to, because I want to know exactly what kind of defects are produced. So what is the stress behind it? Okay. Then I calculate the band gap. The band gap can be tuned from 3.1 eV, okay, to 2.8 eV. This much band gap can be tuned due to this photon absorption. Then I say that what kind of optical phonon modes are there, whether it is a free exciton, whether it is a 1 order optical phonon, 2 order phonon, 3 order optical phonon, how it behaves. All these characteristics I want to know before understanding the optical absorption. So this is a closed aperture and open aperture jet scan technique where I know the optical nonlinearity. Due to this, the equation I am talking in the before, that this polarization is proportional to e to the power square or e to the power q into my nonlinear susceptibility. Then it absorbs, and in a 2 peak, it absorbs in a single peak. So then if it is a in a single peak, this is an open aperture. Aperture is very, very large. That means when the light will come, at a certain point it will be high, then it will go low. Okay. If the aperture is very small, it will get either 1 peak, maxima and 1 minima. So all these characteristics I want to understand. If I fit these equations, all these equations, then I want to know what is the absorption coefficient. Beta is my absorption coefficient, and n is basically my refractive index, nonlinear refractive index. That means the refractive index only depends on the wavelength that we know. Okay, because as a function of wavelength, the refractive index changes of a material. Similarly, the refractive index can be non-linear in the same matrix. Okay, the refractive index as a function of distance you go, it becomes non-linear. It becomes E square as a square of this, all these things. Then this non-linear optical refractive index and the absorption coefficient I calculated for different material, for different percentage of grouping. Then I know that till the band gap of 2.8 eV, okay, I can see the nonlinearity. So from 2.8 to 2.9 eV, I can have a large variation. Then it becomes almost stable. So within this, the band gap tunability, I have a nonlinear refractive index or nonlinear absorption coefficient, which can be used my switching effects. Okay, then I do the theoretical calculations. I put 1 cobalt ions, then I want to see that what is the effect. I put 2, then I want to see the effect. Then I know that where the band gap is coming. This is the theoretically calculate that where the band gap is coming, whether it's a L or N or H bands. Okay, so these are the brilliant zones. From here, we calculate all these things. Then we know the density of states of the electrons. From there, we are able to calculate or understand how this optical absorption, 2 photon absorption, is correlated to tune my band gap. Okay. So these are there are 2 concepts. One is electron photon coupling. In the first part I told. Second part is how the 2 photon absorption helps to get my absorption coefficient or to get my band gap tunability. So these are the two concepts I taught. And finally, in conclusion, I will say that in both the cases, we'll be able to make the devices which will help us for the miniaturization of the silicon industry or semiconductor industry. With this, I thank my students, my postdocs who are working on this area, my collaborators from IUC Delhi, and thanks for your attention.
Okay, thank you, sir. You have explained the aspects of Niger first. How can we enter the Niger? And after that, you have explained about the defects of semiconductor and interaction with electron phonon nicely also. And result of quenching also you have explained nicely. Then thank you, sir, for giving this talk. Now we are having Honorable Resource Person, Professor Samar Bagchi, former Director of Science Museum, Eastern India, Kolkata, and in charge of 5 Science Museum of Eastern India. He is also National Award winner for popularizing science. He is also conducted a popular science quiz called Quest in National Doordarshan from 1983 to 1988. He is a member of the syllabus committee of High School of West Bengal. Today, Professor Samar Bagchi will demonstrate some low cost, no cost experiment in physics for graduate student, and also it will helpful for the +2 students also or high school students also, and they can know very easily about the physics related demonstration experiment with their day-to-day life. Sir, please.
Okay. I would like to thank first the organizer, especially Mr. Tapot Panda, for inviting me to take this program. You have all heard about the recent advances in physics. Now, all these advances has taken place, and the discussion that took place, which I heard a little bit, is theoretical discussion. But in science, theory and practice must go together. If they don't go together, science cannot progress. When Higgs boson was proposed, when Higgs boson was proposed, can you all hear me?
The guardian signature is there.
Yes, sir.
Can you all hear me?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So when Higgs boson was proposed by Higgs, then for so many years, until this was proved in CERN by that great experiment, it was not that much accepted. So is Einstein's general theory of relativity. When he proposed in 1915, he said that if light which travels in straight line, if it goes by the side of heavy gravity, light will bend. And that was proved in 1919. Sir Arthur Eddington, the great astronomer, Royal Astronomer of England, he sent teams during a solar eclipse to find out. So, and then Einstein became very famous. Now, theory and practice must go together. In India, science had progressed in the earlier age. But then when in India, Stark and Sushruth, in Sushruth, dissection of human body was sine qua non for the understanding of human body. But then, because of the sanction by the Shastakaras, that if a Brahmin holds a lancet for cutting the human body, one will be excommunicated. So gradually, because of this, the work of dissection went back to the locus, and the head and hand got separated. So science also started declining. By the Middle Ages, Indian science did not, after that, not much of progress took place. So what I shall do, that to do theoretical physics, experiments should go on. Now I shall start with, because time is short, I shall start with an experiment. I shall show you a toy. This is a toy. Okay, and now why it is coming? Now I hold it here. See what is happening. This blue colored liquid, you see what is happening. So I shall ask questions to the students and they will get only one or two will get the chance to reply. Not many, because I have to show quite a few experiments. You see, the liquid is going up as if by itself.
Sir,
Okay, now
due to high temperature is increasing, so it is
now just a minute,
going rise up.
let me show you. Let me show you first.
Due to
So-
heat, expansion is going in the liquid.
Okay, in the liquid, expansion is going on in the liquid
Absence of heat of hand, it is rises up.
because of the expansion of the liquid. That you say.
Yeah.
Any other answer? It's not that, because this is a very highly volatile liquid, and it's the gas is here. So when you hold it, your body temperature is transmitted inside, and the gas expands and gives pressure to the liquid, and that liquid goes up. That is what is happening. That's the toy. Okay. Now I show you two iron pieces. These are two iron pieces. Nothing else is there with you. Only these two iron pieces. Nothing else is there. But one is a magnet. I don't know which one. One is a magnet and the other is simple iron. And you will be given only, say, 5 seconds time. 1, 2, 3, 4, 5, I shall say. But after that, no time. And you have to tell me how only with these two, by understanding the property of magnet, you can find out which one is magnet and which one is iron. Okay? So this is there now. Now keep the book here. Keep the book here. Keep the book here. Okay. Now I'm keeping the two books, two materials here. Nothing else is there. Now we have to find out which one is magnet and which one is iron. I shall start counting. Ready? Go. 1, 2, 3, 4, 5. Now tell me, which one is magnet, which one is iron? What experiment you will do to find out? You are keeping quiet?
Magnet in the middle.
What will you do? What will you do?
We touch the magnet and the iron in shape of T. That means in the middle portion, we shall touch the
Okay, I shall touch it with the middle portion. I shall touch it with the middle portion. Okay, let me touch it with the middle portion. I touch it and it attracts. Then tell me which one is magnet and which one is iron. Which one is magnet and which one is iron?
To L portion.
Huh?
Sir, I will gradually shift the T position to L position, and I will check whether there is a less force.
Now tell me which one is magnet and which one is iron. This one is magnet or this one is iron? I toss it in the middle and it attracts. It attracts here also. It acts here also. It acts as the middle also. Which one is magnet? This one is the magnet and this is iron. This is the magnet. Because in the magnet, if this is a magnet and you touch it at the center, there will be no attraction. At the end, there will be attraction. At the end, there will be attraction. But at the middle region is known as, you all know, the middle region is called neutral region. So this neutral region will touch, there is no, this is magnet. So it takes 1 second only. If you know the property of a magnet, in 1 second you can say that this is magnet and this is iron. Okay? So this is a very simple experiment. Now, I take a bottle. Now, I take water. I take little water in this. I take little water in this. About a cup of water will do. I take a cup of water. Then I close it. you see that this is transparent. You can see through this. Okay. Now I shake it. Transparent. Now I suddenly press it. Transparent. Lid it. Transparent. 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 Now what I shall do, I shall take a piece of paper. I shall take a piece of paper. I shall take a piece of paper, then I shall light it and then put it inside and do the same operation. Pressing suddenly, releasing it suddenly, and see what happens. Okay, just a minute, just a minute. Let me get ready. Yes, now. Okay. I have put a burning paper and after a while it gets off. Now you see it's still transparent. Now let me see if there is any smoke. Let me drive it out. No, no smoke is coming. I close it again. Then I suddenly press it and release. Are you see it's getting smoky? Now you see how this smoke comes out. Smoke-like thing comes out. I have removed all the smoke. Smoke-like thing. I do it again. I do it again. It has become transparent again. You see, again smoke came out. Again smoke-like thing has come out. What is coming out? Now, when the paper was burning, after that, whatever smoke was formed, that was removed. But when I suddenly press and suddenly release, it is becoming cloudy. What is happening? What is coming out? What is coming out?
Water vapor.
Huh?
Water vapor.
Water vapor. Now, when you stand before a well or a river or a pond, or when you put a wet cloth or a string, it starts drying up. Do you see that water vapor is coming up from an ocean or from a river or from a pond when you stand before it? You don't see water vapor. You don't see water vapor.
No.
You don't see water vapor. It cannot be simple water vapor. But I tell you, it has got relation with water vapor. Now I get also such answer, this is carbon dioxide, because the paper has been burned. Now carbon dioxide, what is coming out? What is coming out from my mouth? Mostly carbon dioxide, not mostly nitrogen. Carbon dioxide is also there. But do you see carbon dioxide? Are you seeing carbon dioxide coming out? No. So carbon dioxide also, nitrogen, oxygen, you don't see. So what is coming out? It has got relation with water vapor. Now when I had shaken it, first at the beginning, water vapor accumulates in the bottle. Okay. Then I put a burning paper. When I put a burning paper, then along with the gas which is formed, some carbon dioxide, a little bit of water is also formed, and there are also some carbon particles in that, which is there in this bottle. Now there is water vapor here. Then when I suddenly press, that's called adiabatic compression. You have already studied in class 12. Adiabatic compression, and then a little heat is produced, a little more water vapor is formed. So this place is more or less saturated with water vapor. When I suddenly release, what happens? It's sudden expansion, adiabatic expansion. Then it cools down. When the air inside cools down, then the water vapor that condenses around the carbon particles and water molecules are formed. That is what you are seeing. What I have created here in this bottle is cloud. The way nature forms cloud, I have created cloud inside the bottle. When I suddenly press a little heat, a little more water vapor, and then this place becomes completely, more or less completely saturated with water vapor, and then I suddenly expand. Now, you have experienced that when sudden expansion takes place, there is cooling. Now, take your palm like this and purse your mouth and do it like this, and then which one is cooler? This one or this? Are you all doing or not? All the students, you do this.
Yes, 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 yes.
When it is cool, which one is cooler? When I purse my lip and blow, cooler, hot. The same air which is coming out from my lungs with the same temperature, hot, cold. But temperature is same when it comes to the mouth. Now, when I try to purse my lip, the air is under pressure inside. And it suddenly comes out when I blow. When air suddenly expands, it's cooled down. And so I feel. Now, if you have a cycle or a car, or it is better if you see a truck which has got very heavy pressure in the tire. Now you take a small stick and press the nozzle, and then air will gush out, and the nozzle becomes very cool. It can become so cool in the case of very high pressure in a truck that, and there is water accumulated around, then water may become ice. That much of cooling. That is adiabatic expansion, which we'll read also more when you do graduation. So these are the three simple experiments I did for you. Now, why do we read science? We read science to understand the process of nature. We read science to understand the process of nature, how nature works, Everything that we do, we use it for our own good. But not that all technology is good. Science, which discovers new understanding about nature's process, how nature works, that's one thing. But when we use the science to create technology, to produce more and more of goods, and do you have any idea of how much of goods are produced? I give you a figure to understand, because you are all young people. Tomorrow, you will become the leaders of the country, either in science or in technology or as politician. Okay? The way we, the elderly people of the world, has made this world which will be unlivable. And this is how being proposed by the scientists of, say, Stanford, Oxford, Stanford, Berkeley, and Princeton. I have got a message from the scientists from there that the 6th Mars extinction is coming. 6th Mars extinction is coming, and the first species that will go out of space of Earth is the human species. That's the type of Earth is coming. So we have to understand how nature works. And we are really trying to use nature in such a way that nature is collapsing. And global warming, climate change, water in the ocean rising, severe situation is happening in the. So I shall do now a next experiment. Just 1 second. Now I shall take up a experiment here, which is very common, but then there are a lot of things to understand in this. This is an experiment which in my time I had read also like this, and the teachers, the scientists who explain now, they have also studied like this in the school level. That in the school, to prove that air pressure is there, the experiment that is proposed, that take water in the glass and then put a card, then turn it round. How much water one has to take? How much water in the glass? What the book says. Take water full to the brim so that no air is left. Okay, this is how students have learned. I have learned also. Then you close it, then you turn it. Then the book says that the air pressure from below keeps the card on this. Okay, let me do this experiment. I take water. I take water in this glass. Full to the brim. Okay. Now I put this card over it. I press it with my hand, then turn it round, and then release my hand. It does not fall. Does not fall. Okay, now let me take half glass of water or little less. Now tell me what will happen now. Will it remain or will it fall?
It will remain.
It will fall.
It will fall, it will remain. Okay, let us see what happens. Ready? It does not fall. The book for 70 years, I am 89 now. For 70, 75 years, this is continuing in books. And they are all copying from one to other. Somebody wrote long time back this experiment. Take water full to the brim so that no air is left. Now this is so much of air, but it's not falling. One student has given right answer. Tell me your name. Your name, please.
Ananya Swine.
Okay, tell me why it does not fall. Now.
Due to the pressure.
Due to the pressure. Now let me explain you. You know that I did a program in television for 5 years. I am a television hero in that way, for which I got a national award. And also along with me, there was one professor of physics, quite renowned here in Calcutta, in India. He also came, and both of us got national award. Both of us got national award for that. Now let me show you another experiment to understand this. What I do, I have here a cup, plastic cup, which has a hole at the back. There's a hole here. Oh. I would like to thank my granddaughter to help me in this program.
Okay, thank you, sir.
She is an educationist. She is in education, doing his PhD in education, but she is helping me in this program now. Okay.
Okay, thank you.
I have to come to my daughter's house about 7 kilometers from my house every time I do. This is the 7th program that I am doing in this webinar program. Okay, now I take water here. What is the other one? Okay. I take water. At the beginning, I keep the hole closed. I shall keep the hole closed. I shall keep the hole closed like this, and then put the water. Okay. Now I put this card and keeping the hole closed, I leave my hand. Sorry, once more, give me water. This plastic glass, but it's very soft. Okay. Oh, this is okay. So it's not falling. Now I shall open this one. See what happens. Do it again. So that, give me again. More. Yes. Keeping it closed. No. This hole, there is another hole. What? Okay, okay. Let me take it again. I'm not closing the hole properly. That's the reason it's happening. Oh, yeah. This is.
It's on the side.
Oh, this is the other one. No. This is wrong. Yeah, I've taken. You see, what happens if you make the hole properly? Close the hole. I showed you at the beginning that it fell down when I open it. When I open it, this is connected to the atmosphere. When I open my finger, this is connected to the atmosphere. So normal atmospheric pressure works on the water surface, and that is normal atmospheric pressure working here on this card upward. So this pressure and this pressure cancel out. So due to the weight of the water, it falls down. Okay. So what is happening then? Tell me in this case. When I close it and leave my finger and it does not fall, but when I open it, normal atmospheric pressure works, it falls down. Tell me when when I keep it closed and leave it, what is the pressure then? Is it normal atmospheric pressure?
Vacuum pressure.
If it is a normal atmospheric pressure, it should fall down. Because when I open it, it falls down. So if this is normal atmospheric pressure acting downward on the water, it should fall down. But it's not falling. What does that mean? Pressure inside has gone down for some reason. Definitely it has gone down. And what is happening then? What is happening? What happens? Now, for that you have to understand something. Now, here I have water in this glass. What is the pressure acting on the glass? What is the pressure acting? What is the pressure acting on the water here now? What is the pressure acting?
Atmospheric pressure, sir.
You say normal atmospheric pressure. Normal atmospheric pressure is working. Now tell me. Normal atmospheric pressure is working. Now tell me, when I close it, what is the pressure acting now? I have closed it. I have cut off the atmosphere on the top. Tell me, what is the atmosphere? What is the pressure on the water now? Is it same, less, or more? You see, same, here sir. Comes. Huh?
Same, sir.
Same. Why same? You are right, but why same?
Sir, because the amount of air resides in the glass is same. So
okay, wonderful. So when it is open, yes, you are right. When it is open, what happens? The probability of the molecules. Why air pressure comes? Air pressure comes because all the molecules in this room, are they stationary at this temperature of 30 degrees Celsius? No, they're all vibrating. At what temperature all the vibration of these molecules will stop?
At room temperature.
Absolute zero. Absolute zero. 0 degree Kelvin. Okay, minus 270 degrees Celsius. All the movements will stop. Pressure is zero. Temperature is zero. Volume is zero. Now, as the temperature goes up, then it starts vibrating. More the temperature, more the kinetic energy of the molecules are very high. So when it moves like this and hits my head for 89 years, I get bald. Okay, that's a joke. Okay, so when they hit something, then that thrust or the force per unit area is the pressure. Now suppose there are 100 molecules inside. The probability of these 100 molecules to strike at the side of the glass or on the water is more than what is there, say 100 feet or 1 mile up in the probability is absolutely more or less zero. So probability of the molecules, of these 100 molecules which is inside this, what the student said is same now. Number of molecules is same. temperature is same, so pressure will remain same. Okay. Now, see, the same water goes up when I turn it round. When I turn it round, the same water goes up. The same water goes up, same air goes up. See, that was in atmospheric pressure. Now also it is atmospheric pressure. So what will happen? Atmospheric pressure plus this water pressure is more than the pressure acting upwards. What will happen? This card will try to go down slowly. So it tries to go down slowly. And when the pressure inside becomes less and less, and this pressure plus the water pressure becomes equal to the pressure upward, then it does not fall. You see? It does not fall. Okay. Once more. Once more. See, it is floating. You see, it is floating. That means it come down a little. This level will come down also. And when it comes down, this enclosed air expands a little, so the pressure goes down. Pressure goes down. Okay, this is what is happening. Now, when the enclosed air expands, the pressure goes down. For that, what kind of experiment you can show to the to your class friends when you go back to your college, or to the younger students if you want to show? You take a syringe. You take a syringe, and by that you can show a lot of things. Many experiments can be done with syringe itself. Okay, give me a little water. Give me a little water. Okay, now this is the syringe. Now this is the piston. Oh, this is giving me trouble. Can't you close it continuously? Okay. So you see, here is the piston. This side is open now. So normal atmospheric pressure is acting on the piston. Now this side is also open. This side is also open. So normal atmospheric pressure is acting on the piston from this side and also from this side. So it remains there, does not move. Okay. Now I press it to the end. Now when I close it with my finger, tell me what is the pressure on the piston now? What is the pressure on the piston now?
Outside.
Is there air here? Is there air here?
Air inside it? No.
Very little air is there. What is the pressure of that air? You have just learned whether it is open, whether it is closed. No, very good. Normal atmospheric pressure is working now. Okay, now this is very small amount of air here. Now I pull it. What happens? That air will expand.
Cannot pull it.
And now I leave it. Who pushes it? Did I push it?
No.
Did I push it?
Yeah.
No.
No.
Who pushed it?
The vacuum pressure.
Vacuum pressure.
No,
Some
normal
amount of
atmospheric
vacuum has been created. Atmospheric pressure from this side. From this side, atmospheric pressure.
Low atmospheric pressure.
Low atmospheric pressure inside. Low atmospheric pressure inside. Why? Because this small amount of air has expanded. When a small amount of air, enclosed air expands.
Bernoulli's theorem is working there, sir.
No Bernoulli here. No Bernoulli here. Bernoulli is different. Bernoulli will be like this. This is Bernoulli. But this is not Bernoulli. This is simply this amount of air, this small amount of air, which is enclosed now. This side is also enclosed, piston is here. So what happens when I pull it? That small amount of air expands. So pressure has gone down. So the atmospheric pressure presses this. And how can we understand? If you want to explain it to a class 7, class 8 child, you should do it. We are all college students. You should do some voluntary work. go to the school, show such experiments so that their understanding becomes better. Why is it that Indians are not getting that much of Nobel Prize? We have very few. From Indian, really, only one, C.V. Raman. There are other Indians, but they're naturalized Americans. They are not Indians. I mean science. In other subjects, there is, but in science only C.V. Raman. Why? There lack of intelligence? No, no. The way we learn science, that is the problem. That is the problem. Now, how you will explain to a class size child? You tell them, suppose you have come to a class where there is no table or chair, no benches, it's completely empty. And it is on 31st December, which is a new moon day, Amavasya ka raat hai, new moon day. You have all assembled in that room in the night to bring in the new year. So you decide that you will start dancing and song when the bell rings 12. So they have all accommodated there. There is big music arrangement. So at 12 o'clock when the bell rings, the music starts and they start dancing. New moon day, suddenly the power goes off and it becomes pitch dark. But they're all enjoying. In that darkness, they're still dancing. What happens? Some of them will go and hit the wall. Say 10 students hit the wall, and that creates some pressure on the wall. Because of that hitting on the wall, some pressure is created. Now suppose in the same night, in a room which is 10 times bigger than this, length and breadth 10 times bigger, and the same number of students are there, and the light goes off, but they continue dancing. Will the hitting against the wall remain same, less, or more?
It will less.
Less. That means pressure will be?
Less.
Less. That is the same thing which is happening here in this glass experiment. Also in the case of when this expands, small amount of air expands, what happens? The pressure goes down because it has got more area to thrust now, more area to give the force. So the pressure goes down. So the air pressure forces it in. Now, does the air pressure act only from this direction? Now it is in this direction. Now, this direction. So air pressure acts from all directions. So with a simple syringe, which is all thrown away, creating pollution problem, plastic pollution problem in the whole world. There will be no fish. It will all be full of plastics now in the oceans. The way we are all living. Consumerism. Consumerism. That's what is happening. So let me go to the next experiment. Now this experiment, there's one more thing. I think I should do that experiment. That's a marvelous experiment. Let me see if it becomes successful. What I do, I take water in this. Yes, I shall keep it here. I have a, where is that? ইয়েটা কোথায় গেল? এই প্লাস্টিক প্লেটটা ছিল কোথায় গেল এখানে? এখানে রাখলাম যে? হ্যাঁ? না না, এটা এরকম প্লাস্টিক প্লেট ছিল, এখানে ছিল তো এর উপরে। আরে এই মাত্র এখানে রাখলাম। এখানে প্লাস্টিক প্লেটটা এখানে রাখলাম তো। এই যে এই যে ওকে। So I take water here. I take water.
Last session da pura interest.
ওটা রাখো কেন? জলের দরকার নেই, জলের দরকার নেই। This is a very tricky experiment. কোথায় গেল ইয়েটা প্লেটটা হ্যাঁ আচ্ছা now what I do now I put this plastic plate over it. Can you see the plastic plate? Can you see the plastic plate?
Yes,
I can see it. Okay, now I
Yes,
turn
sir.
it round and keep it on the mug, over the mug. Okay. Now what I do, I have got coins here. I shall put this 10 rupee coins, 3 10 rupee coins below it. (120° apart). Standing. Okay. Then I put 2 more. Then I put 1 more here. One more here. And 1 more there. Okay, so it is up by about say 3 millimeter. It's up. This is nearly 1.5 millimeter thick. It's nearly thick. I can put 3 more. I want 3 more here. Then also I can do up to 3. But there is one professor who also goes around all over India, Dr. B.N. Das. He can put 4. He can put 4. He's so adept in experiments. But I am afraid to put more than 3. I put 3. I didn't get the coins. I forgot to bring the coins. Now what I shall do, I shall take a syringe. I shall take a syringe. Take soap solution. Take soap solution. I have got soap solutions here. I have got soap solution in this. I take soap solution and then I shall put soap solution at the bottom of the glass. When I give soap solution, you see the water level is coming down. Okay?
Carpenter
Why it is coming down? Give me one more. Once more.
I say prudential.
If I
say prudential.
Huh? What?
Surface tension is decreasing.
Surface tension is decreasing. You see, surface tension is decreasing. So it's coming down. So surface tension also has a role in this. Surface tension also has a role in keeping the water level there. But then surface tension is not the main reason. If that was so, then when I do this experiment with when I do the experiment with this plastic glass and I open it, it should not fall. If surface tension was responsible for holding the weight of water, when I open it, it should not fall. Okay. So take a plastic glass which is a little thicker. Here it is it's not that much thick. So you take and then hold it like this, close it down, and then do this experiment. When this is open, then normal atmospheric pressure is working, it is falling down. If surface tension was responsible, then it should not fall. But it has got a role also. But the main reason is the air pressure is going down. When this plate comes down a little, the level of water goes down a little, and the inside air expands, pressure goes down, then this pressure and this pressure together is equal to this pressure, then this does not go down. This is what is happening. So, now you have to remove this there. That's it. Now you remove it. Remove it that side. Remove it that side. Okay. Now good.
Wait. It's okay.
Okay. Okay. Now I have done this. Now let me show you another experiment which is there in the books. This book. Give me a thick book. This is 20% oxygen experiment. I think those who are now studying in college, they have read this also. Then experiment to prove that air contains 20% oxygen. What the experiment says? Light a candle, put water, then put a glass over it. Then when the oxygen is finished in the glass, when the oxygen is finished in the glass, there is partial vacuum. Then air pressure forces the water in. That is the explanation that is given. Let me show you the experiment. I have taken colored water so that you can see it.
Nobody can see.
I take colored water so that you can see the water is rising. Okay. Now I take colored water and then I shall light the candle, light one candle, only one candle, like this one. ওর থেকে না এই যে এখানে রেখেছিলাম এইগুলো নাও, এইটা নাও, এইটা, হ্যাঁ, হড়বড় করো না, আরো আছে, একটু জ্বলতে দাও, তারপর আনো, এইটা না। These days, these matchboxes also become spurious. নিচে রাখতে হবে, এরকম ভাবে রাখতে হবে। হ্যাঁ, না এইটা লাগবে। I put only one candle. Acha. Now I put the glass over it. No water is rising. No water is rising. Now, as it goes off, the water is risen. What the book says? Divide this glass into 5 equal parts. Divide this glass into 5 equal parts. And the book says, when all the carbon dioxide is consumed by the candle, then water rises 1/5. If the water rises 1/5 of this glass, that means air contains 20% oxygen, because all the oxygen has been consumed by the carbon. That is the explanation given in the book. For maybe 60-70 years this is continuing. Okay. Now see, I shall do the same experiment with 3 candles. See what happens. Just a minute. Just a minute. Now, if I now use the same glass, that means the amount of oxygen is same in the previous case and this case. Do you agree or not? Amount of oxygen will be same?
Yes.
Okay? Oxygen will be same. So, there are 3 candles. Will it go off much quicker or later? 3 candles are burning and I put it over it.
Sir,
Much earlier. Because it will consume that much of air, oxygen very quickly. Let us see what happens. Now, put on. এরম হবে না, হ্যাঁ, একটু জ্বলতে দাও, হ্যাঁ, এবার নাও, 3টে। Now I am putting all the candles. Now I am taking 2. Okay, let me see with 2. Now see, it is more than double. It wanted more air to come. There's bubbling. Same air is there. Same amount of oxygen is there. Now it is rising more. It would have gone this. If it is 3 candles, it will go this. If it is more, then it will go still higher. That means I shall go on changing the percentage of oxygen in the air. If 1 candle gives 20%, that means if there are 5 candles or 6 candles, it rises more. Then I shall see oxygen content is more than 20%. It's an absolutely wrong explanation continuing in the books of India for 60-70 years.
So,
I shall not tell you the story how it was removed from the NCERT books. I shall not tell you. I was a member of the NCERT committee, one of the committees, and there I explained this mystery, what is going on in the books. Now, what is happening now? That you have to understand. Why it is now rising more. It's nothing to do with percentage of oxygen. Why? Because when the oxygen is consumed in this glass, another gas is produced. What is that gas? Carbon dioxide. So C plus O2 is equal to CO2. That means if one volume of oxygen is consumed, one volume of carbon dioxide is produced, and which is inside. Why there will be vacuum? So that air pressure will force the water in. Vacuum is created, definitely. And that is the reason why air pressure from outside forces the water in. If the carbon dioxide is same volume as oxygen, nearly same, because a little bit of water vapor is also produced. What is happening? So what is happening is this. When I bring the glass down, over the candle, what happens to the air inside? It gets cooler, hotter, or same? It becomes heated. Hotter. And when air gets heated, what happens? It expands, remains same, or contracts? It expands. And when the air inside tries to expand, it goes out. That it goes out, I shall show you that it goes out. Now I shall do that experiment to show you that it goes out. Now I shall show you with a bottle. Just 1 second. Let me take the bottle. Okay. Now what I shall do, you have to watch what happens in the water when I put this over the candle. I shall put this over the candle, on the burning candle, and you observe what is happening in the water. Yes. Be careful, be careful. Now I shall put this over the water. See what happens to the air inside. See what is coming out. You see bubbles here. Bubbles coming out. The bubbles coming out. Where from the bubbles come? Bubbles mean air. Where from it is coming? From inside this bottle. When see now the pressure has gone down. When the candle over the candle, the bottle is placed inside the bottle, air gets heated and it goes out. So there is this bubble. That air goes out is proved by this. Seeing the bubble that is coming out, that air is going out. So when you go and show a class 7-8 student these experiments, you have to explain everything in a very, very clear way. What is really happening? This is not done in any school of India. Not done in any school of India. It's all rote learning which is taking place. I have taken more than 300 workshops for the science teachers in India. Situation is not good at all. Okay, so let us remove this. Okay, now let us remove this. Can you take it there and throw it? Yes, yes. Yes. Do you have any question on this? A girl was asking something? Okay. Because time is short, let me go on. Let me go on with the experiments. At the end, if there is time, then you can ask questions. Now let me show you an experiment like this with the two these straws. What I shall do, I shall put this straw on this side. I shall put it inside. I shall put it inside. Okay. Okay. I put it inside. Now I make it nearly 90 degree here, also 90 degree here. Now make it at right angles like this. Acha, now what I do, I blow air through this. You have to put this at right angle. See, this is at right angle to each other. Now I blow air through this. See what happens. Put your hand lightly here, lightly. It's not rotating. Why does it rotate? What law it explains?
Newton's law of motion.
Newton's?
Newton's third law of motion.
Yes, exactly, yes. And to prove that, what we will do, still more, that it is equal and opposite. Okay, Newton's third law says, action and reaction, they are equal and opposite. Now what I do, I close this end with a paper. I close this end so that no air can come out. No air can come out. I shall close it with this paper so that no air has come out. Can you tell me what will happen? Now if I blow, what will happen? What? What might happen? If I blow it now, let me close it properly. Let me close it properly. Come on, go in. Go in and close it properly. Okay. Now I blow. No movement. What does it prove? There was air was coming out. There was reaction on this side. So it made to go this side. Now air is forcing also on this one. So it's not coming out. So there is a force on this side on the paper. So this body is getting a force on this side and there is a force on this side. They balance. That means that action and reaction are equal. Action and reaction. And for that, you need two straws. See, when I press, blow air through this, the air goes like this, air goes like this, goes like this, comes here. The pressure is in all direction, this direction, this direction, this direction, this direction. The pressure which goes in this direction, if it is open, then it goes out. But the pressure in this direction gives a force on this side, it starts rotating like this. Just a minute. Okay. So with a straw, if I, as a teacher, I take a straw, two straws in the classroom and do this experiment to explain to a child that why Newton's third law, why shouldn't I do it? These kinds of experiments should be done in the classroom while a teacher teaches a subject. Now let me show you. I shall take a magnet. I shall take a magnet. No, not this one. I shall take a magnet here. I shall take a blade. I shall take a blade. Where is the blade gone? The blade is here. Blade ta kothay gelo? Dekhecho? Ekhane blade ta chilo. I had kept this blade here. No. You see, this was here. Just now it was here. আচ্ছা এর মধ্যে না দুটো ব্লেড ছিল আচ্ছা এর মধ্যে একটা ব্লেড রেখেছি দেখো তো ওখানে সব বের করে দাও ওটা না ওটার মধ্যে নেই এর মধ্যে দেখো it was here where is it gone এখানে ছিল ওর মধ্যে আছে ওখানে ওটা বার করো ও একদম নিচে বের করে দাও না সবকটা ফেলে দাও এখানে ফেলে দাও just a minute let me find out the blade ও ব্লেড আছে ওর মধ্যে, ওই কৌটোটার মধ্যে। কৌটো আছে দেখো একটা। কৌটোটা কোথায়? ওই যে ওর মধ্যে আছে, ওই যে একটা ব্লেড এখানে ছিল। নাও I shall take a blade. I shall take a blade and I shall magnetize it. I shall magnetize it. I take a magnet. This spotted end is the North Pole. The spotted end is the North Pole. Okay. Now I take a magnetic compass. Also, here is the magnetic compass. This is showing north. This is showing north. This is south. Okay. I keep it here now. Now what I shall do, I shall magnetize this blade. The book shows two pieces. One is a magnet, one is the iron of this size. The book picture shows like this. And it says that you rub it and it will become a magnet. It will never become a magnet. You can't make a bar iron of this thickness just by rubbing with another magnet of this size. But you can make a blade magnet very easily. How you see? I shall put this north end. This is the north end. I shall put it here. I'm holding it on the side. And then I rub it only twice. And then I take it to the north end of the needle. First, let me take it to the south end. Repelling. And you know, repulsion is the shearer test of magnetism. This has become North Pole. If you start with a North Pole, from here, then this side becomes North Pole, this side becomes South. Okay. Now, this can become a very good. Give me a glass of water. This becomes একটুখানি একটু কম। না এটাই same. Now this blade, after making it a magnet, can act. If you don't have magnetic needle or a magnetic compass, if you don't have in the school a magnetic compass or a needle like this, you can make your own magnetic needle by using a blade only. See what happens. I take it here, and then I take a little more water. Okay. Now this side I started with north and it became North Pole. Now I'm putting this on the south side. Now the North Pole is now pointing to the south, this side. Now let me put it here, see what happens. It has turned again and gone to the north. You see, it has gone again, showing the north. I do it again. I turn it round, and the north end is showing south now. Now I again put it on the, just a minute. Now I'm putting it on the water. See what happens? It turns around. So it has become a very good magnetic needle, like a needle. So you can use this in the school if you don't have your own magnetic needle or magnetic compass. Okay? And understand, if I start with south, I can make this now. This is North Pole. I can make this South Pole. See what happens. Then what I have to do? You can do it with a blade. but not with, you can't change the polarity of another bar magnet, another bar magnet. Now what I do, this was the North Pole, huh? I say 1 minute, 1 minute. Now, this is the 7th webinar program I'm taking, and I have to come all the way to my daughter's house, and my son-in-law helps me in this. Today, of course, my daughter was helping. Now son-in-law has come, so he's trying to improve the situation. I think improving the situation.
Okay, thank you, sir.
Okay, now you see, again, this blade, I shall show you the which one is North Pole. Now it has turned. Now this end is showing the north. Now I take it like this. So this is the North Pole. Now what I shall do, I shall make this South Pole. I start with South Pole and you see how it will change. I take a magnet. This is the North Pole. Now I take the South Pole and start rubbing in the same way. I start with South Pole. Now you see what happens. So I've started with South Pole here. So what polarity will be there? It should be South Pole. Now if this will be South Pole, if I put it like this, it should turn. You see? It's turning. So polarity has been changed. So you can change the polarity of a thin thing like this or a pin. You can change the polarity, but not a bar magnet. You can't change the polarity of the bar magnet by. Okay. So this is a very simple experiment on magnetism that I showed you. Now, you see, I have here pins. I'm taking pins here. Now, what I do, acha, ওখান থেকে আমাকে ইয়ে দাও।
Thank you, sir.
ছোট একটা কৌটো আছে দেখো, ওই কৌটোটা। এই কৌটোটা। আচ্ছা, now, now this is aluminum, and aluminum is not a magnet. It's a magnet. It's a paramagnet. It's not a magnet. So it's not attract. To attract this pole, you need very, very strong magnet. A paramagnet also gets attracted by a magnet, but the magnet has to be very, very strong. And that experiment also is, I have not brought it. That experiment, Dr. B.N. Das, he does that experiment so well. And we have two teachers here in Calcutta who shows these experiments also. Now, what I do, I take a magnet and put it over it. It's not attracted. So I am taking it near the. How is this attracted? Lower one? Why it is attracted by the upper pin? Definitely the upper pin has become a magnet. And this magnet that I have kept on the top, if I remove it, see what happens? It falls down. That means magnetism which is there in the pin is a temporary magnet. And that's called induced magnetism. The magnetism is induced. That pin has become a magnet now. So it can pull another one. And it is trying to pull the third one. Fourth one, my Lord. So four pins have been, so each have become a magnet. And when you remove the magnetizing effect of this upper magnet, it all falls. This is induced magnetism. But see what happens if I take a very strong magnet like this. New medium. I now take a very, very strong magnet, and I take now a few more. There are 6 now. See how many it can take. It can take a few more also perhaps. Okay, if I could do, so it is taking, the same thing happens. If I remove it, it goes. Very strong magnet. So this is magnetic induction. You don't need a aluminum plate for that. You take a copybook and you can do the same thing. You take a copybook, put the magnet over it, and do the same experiment. I had this, so I did it. But then it's not necessary that in the school you need a plate like this. You use just a copybook of a child or a book of a child, thin one, not very, very thick, and then do the experiment. The same thing will happen because paper is also a non-magnetic substance. Now I shall do an experiment with, again, water. I have here 2 test tubes. One test tube can go inside the other. It should not be too tight, not too loose. Not too tight, not too loose. See what happens. I take water. And I fill it up with water first. See, I have filled up with water. Okay. Now I put this one inside this. And then I just turn it round. This tube is now anti-gravity test tube. It is going up by itself. Let me do it again. See, it is going up. It's going up. As it goes up and up, it becomes faster. Firstly, is it going against Newton's law of gravity that is going up by itself? If I leave a body, it falls down because of gravity. But here, the inert test tube is going up by itself. That means the inert test tube is forced upward. By what? By the air pressure. Because of the air pressure, normal atmosphere is acting because this side is open. So normal air pressure is acting on the inside tube. And that, what happens? If you have noticed, you have seen that as I turn round, drops of water start falling. See again. Observation is one of the very important things that a child has to do. Start observing around. Why the society is like that? Why there is so much of richness and poorness? If you read the report of the Oxfam of this year, 2020, how poverty in India is growing, rich and poor divide is growing. You have to understand everything. Now you see that drops of water is coming down. Can you see the water coming down? If the water starts falling, it must be falling from this outer tube. And where it will be empty? It will be empty at the top. When a drop comes, this becomes empty. Empty means that becomes vacuum. And if a place becomes vacuum, then air pressure forces it up, forces the water up. As the inside test tube is going up and up, the weight of water against which it is working, that also becoming smaller and smaller, less and less. So the force acting downward becomes less and less. The weight of the water becomes less and less, but the air pressure remains same. So as it goes up, the speed of this inner tube going up becomes more and more. That's what is happening. So this is an air pressure experiment, but it's a marvelous experiment as if it is not following the law of gravity. So I call it an anti-gravity test tube.
So isn't there any role of surface tension?
No, no. Surface tension cannot give so much of force for this whole test tube to go up. Surface tension might be there, but that is not a force that is acting upward to make this body go up. Because the water is falling, then some place in the outer tube becoming vacuum. Where from it is falling? The vacuum will be on the top.
Yes, sir.
That is what is happening. Now, let me show you a gravity experiment. Let me show you a gravity experiment. Okay. Now, this you have to answer first. I've got here a plastic bottle. This lower portion has been cut of this bottle, of a say 50 cc bottle or 75 cc bottle. I've cut and now what I have done, I have taken 2 rubber bands, a little strong rubber band. I mean, jol khabo. Strong rubber bands. I cut the rubber bands. So it has got 2 ends. One end I tie it with a nut here. And the other one also I tie it with a nut. And I have made a hole here. The other end of the rubber band, I have brought it from this hole and tied it with a James clip so that it doesn't go in. Okay. Now you have to tell me. This is called prediction. In science, if I have a theory, I can predict that this might come. That is what Einstein did. Einstein predicted that if light that goes by straight line, if it goes by the side of a very heavy gravity, then light will bend. That was the experiment which was done in the Principe Islands and arranged by, as I said, the Royal Astronomer of England. Now tell me, these 2 nuts are hanging. They are tied here, so it cannot go in. Now tell me, if I release it, what will happen? When it is falling freely, what will happen? Will this remain like this and fall, or some change will be coming? Tell me. Any prediction? What might happen?
Question?
I can't hear. Tell me again.
Sir, the
matter. Yes.
Which are tied. These substances which are tied to the elastic rubber band will be float little up due to the air resistance, and as the gravity acts with
okay,
same.
Let me show you. Huh? No, I shall release it. See what happens to the 2 nuts. See again. Can you see it? Can you show it? I shall release it and see what happens to the nuts. That's enough. It has gone in. It has gone in. It has gone in. It's difficult to show. Let me show the experiment, then you can do it at home. In the school, you don't need a very heavy nut. Just take a small nut, this side and this side, both, and then you allow it to fall. It's going in. Why it is going in? Why it is going in?
As the air.
It's a marvelous experiment. Yes, tell me.
Because of air resistance.
Huh?
Because of air resistance.
Because of air resistance. If the air resistance is there, that resistance cannot make it. If you take this one,
force to the knots,
if you take this one, this falls. Air resistance cannot keep it up.
Sir, when we catch it, we give some upward force, and because of that, the knots will enter into the cup.
No, this is what you are doing is science. This is what you are doing is science.
Sir,
Science has progressed by making mistakes and mistakes. We take it to be granted. We who are doing science, we take it.
Force.
What reaction force?
From hand.
Sir,
from hand? No, when it is falling, it is going in.
When it is struck with the palm.
Now let me hear that other one who is talking about elastic band. Yes, tell me.
Sir, the elastic potential of the band will first be stretched, and in the second step it will be recovered so that the nuts will be attracted towards the center.
So elastic band has a role to play, but why it is not going now? It's not going now. When it is falling, it goes in. When it is falling, it is going in.
In this
case, yes.
In this case, the weight of the knots are pulling it down, so it can't go inside the bottle. But when falling down, the air works as the gravity has no role to play, as the system whole is.
Gravity does not work here.
Yes, gravity works, but the
then
system
you are
is
coming to the
the whole system is falling down.
So
every substance in this system experiences the same gravity acceleration due to gravity, so there is no extra weight on the knots.
No, good. You are trying very well.
Sir, energy conservation.
No, not energy conservation. Very simple.
Sir.
Very simple. See what is happening.
Sir,
a freely falling body has no weight. When I release this body is freely falling under gravity, under full gravity. So this nut, this body, everything becomes weightless. But the elasticity of this band is there. So that elasticity doesn't depend upon gravity. That because of the stretching of the molecules, that has
the gravity pulls everything with equal acceleration. So
that's one at a time. Yes. No, that's all right. If they have equal acceleration, they should go together. Acceleration is same.
It is due to the
No. Listen to me properly. Listen to me.
Yes, sir. That is a free fall body, sir.
It's a free fall body.
Yes, sir. It is weightless.
It is weightless. Now, weightless, but gravity is full. You see, I was taking a workshop at Delhi, and Rakesh Sharma, who was the first Indian to go to space, he was called in the museum to distribute prizes. And it was small children of class 5, 6, 7, 8, they were there to take the prize. At the end of the function, he has just come to the land, and he was called. And at the end of the function, when the prize is over, a small child of class 5 got up and asked Rakesh Sharma, Mr. Sharma, sir, I saw you floating in the spaceship. You became weightless. Why did you become weightless, sir? So Rakesh Sharma answered, because there was no gravity. When he said that, at the end of the function, I told Mr. Sharma, you have become a celebrity now. You'll be called all over India. But the answer that you gave to the child is palpably wrong. So why? I told him that I can make you weightless in this very room under full gravity. Well, how? And that I do. That experiment I do when I go for workshop. I ask a student of say class 9, 10, 11, 12, take the heavy bag that he carries, book bag, put it on the table. And then I ask him that hold the book on your hand and keep all your attention on the weight of the book. And then you just fall on the floor. Just drop down on the floor. And you have to tell everybody what is the weight of that. Is it remain same? It becomes more, or it becomes less, or no weight. Every experiment, the child says, sir, it becomes less. Why? Because a body under free fall doesn't have reaction. Weight comes in a body when there is a reaction on the body. I'm sitting here on a chair. The floor is giving reaction. When there is reaction, there is weight. Weight is not a property of matter. If I am there in a mood, my weight will be less. If I go on the sun, my weight will be much, much higher. But mass is a property of matter. Doesn't matter whether I am in earth or in the moon. Mass remains same. But weight changes because amount of gravity changes because moon is smaller than earth. So that is what a very simple experiment. Let me explain to you. Take two rubber band, cut it. Then at one end you tie a nut. It need not be a big nut. Make a small nut. So, and then make a hole on this plastic and then bring the other two ends outside and tie it so that it cannot go down. And then you let it fall. And you make it fall from the top, but you can't see it in this here. Can you go a little far? Can you go a little far? Will it come? No. Is it coming? Shall I do? Now see, it has gone in. Now this is toned down. Okay. So this is an experiment which now I shall do. What is the time? Now Mr. Panda is.
Yes, sir. Now
can I continue a little more?
No.
Can I continue a little more?
No, sir. Now time is more, sir.
Okay. So I should close now.
Yes, sir, please.
Okay.
Okay. So I shall close now.
Okay, sir.
Okay. It's already 1.
1 o'clock, sir.
Okay, so I am closing now. I have many more experiments here. Let me finish it with one experiment. Let me end it with one experiment.
Okay, sir.
No, thank you,
Last
sir.
one. Total substance. Now, here I have 2 ring magnets. They are in attractive mode. 2 ring magnets. They are in attractive mode. Okay? They are in attractive mode. And each weighs 100 gram. Each weighs 100 gram.
They're clearly not hearable.
Can you hear me?
Yes.
Yes, sir.
Now see, total weight is 200 gram, about 200 gram. So each is 100 gram. Each is 100 gram. Now what I do, I take it out from your view. And now what I do, I keep the magnets in a repulsive mode. See what happens. It floats. Because of the repulsion of this one, this floats. I keep it here. Now you tell me what will be the weight of this now. Is the 100 gram is floating now. This is 100 gram, this is 100 gram. It will be? You said something?
Same weight.
It will be same. It will be same.
200 gram.
It will be 200 gram. Let us see. Let us see what. is 200 grams. Weight remains same. Now you have to explain why it remains same, though it is floating.
Sir, as because it is
Your
floating,
question is right,
so
but why it is same? It is floating. It is not touching bottom.
yes,
Explain why.
sir. Sir, the upper magnet transfers
Yes.
its weight
Tell me.
to the lower magnet. Sir, the upper
The,
magnet transfers its weights to the lower magnet.
Yes, he is getting a
And
force
thus,
on the lower magnet.
It is just like a father. Yes, sir.
True.
Just
This
like
is
the
giving a,
father holding his
the
child
lower
on
one is giving a
the-
force upward, and the upper one also giving a force downward, magnetic force. They're same.
They are
But then
cancelled
why
together.
why this weight is added? I agree that the magnetic force of the lower magnet on the upper one and the magnetic force of the upper one on the lower one, they are same. I agree with you. But then why the weight of this is added? Now this upper magnet is floating because of the upward magnetic force, and the lower magnetic force is also same. And this upper magnetic force is balancing this weight. That means this force and the weight is same. That is it is floating. If this force was more than the weight, it will go up and float. So when it is floating, it means that the weight of this magnet and the force due to magnet, they are same. If that be so, then this force and this force is same magnetic force. So the weight will be added. Weight is added. Because this force is equal to the weight, and this force are same, so the weight of the magnet is added. Okay, with this I end, and I would like to thank you all the students for this marvelous participation. You have all tried, and that is what you are doing. Science has progressed by making mistakes on mistakes. One of the important aspects of science is falsification. By falsifying the previous concepts, science has moved. Okay, so we have no guru. We have no Dharma Granth, no Bible, no Quran, no Gita for us, no Ved for us. Our books are all constantly changing, Sometimes it is Aristotle's physics, sometimes it is Newton's Principia, sometimes it is Einstein's theory of relativity. So it's expanding. Okay, thank you very much. Thank you very much. Thank you all. Thank you, Mr. Panda.
Okay, sir. Thank you.
for the excellent demonstration.
Thank you, sir.
Thank you, sir.
Okay, I take the thanks.
Thank you.
Now there will be
Yes.
a question answer round. So, sir, please question answer the answers of the participants, which will
Okay.
be written by the expert of our college, that is Dushmanta Kumar Das. Now he will ask the questions of the participants to you, sir.
Now, if it is higher physics, I can't, because I am not a physicist.
Okay, sir.
So, but then the experiments that I have done, based on that you ask the experiments. There are a lot of other experiments which I could have done, but no time.
Okay, sir.
Already
Now,
nearly one. Tell me.
okay, sir. Now the questions on the experiments, if any questions by the participants, then they will ask you, sir.
Sure.
Okay. Dushmanta sir, please start. If the questions are there in the chat box related to Professor Samar Bagchi. Yes, sir.
Now, it may be that if they have question, I give the students my email ID.
Okay.
Please write down my email ID.
Okay,
You
sir.
send the questions to me and I shall answer within a day. My email ID is, take your pen and paper, Shamar, S-A-M-A-R, Shamar, S-A-M-A-R, Shamar dot, give a dot, then Bagchi, B-A-G-C-H-I, Bagchi, B-A-G-C-H-I, then at the rate yahoo.com, yahoo.com.
Okay, sir.
Yahoo.com.
Okay, sir.
Shamar.bagchi@yahoo.com. If you have any question, then you can send it to me. If I don't know, I shall ask a physicist and then I shall let you know. Okay?
Okay, sir. Thank you. Sir, then
Okay.
question for
Thank you.
first person. There is a
Yes.
first spokesperson, Ahmad J. Obed. Sir, please hear me.
Yes, yes, I can hear. Tell me.
No, sir. Question for first spokesperson, Ahmad J. Obed from Iraq.
I couldn't understand. Yes, again.
Questions for first spokesperson, Ahmad J. Obed. Sir,
How much?
from Iraq. Not for question for you, sir.
So what is that question?
No, question for you. Not for you, sir.
No, let my son-in-law. I am not understanding the question.
Question is not for you, sir. Question is not for you.
Question is not for you.
Huh?
বাচ্চাদের জন্য question.
Oh. Oh, okay.
Question is not for you. So this is for first spokesperson, Ahmad J. Obed from Iraq.
Oh, acha.
This is not for you, sir.
Oh, it's not for me. Okay.
Okay, sir.
Okay.
Then, Dushmanta sir, please start the questions from the chat box. It will given by the participants. Ahmad J. Obed, sir. Professor Ahmad J. Obed.
First question, can we convert the limitations of log file into its application?
Okay.
Asked by the Pallavi.
Sir, Ahmad J. Obed, sir. Ahmad J. Obed, sir. Professor Ahmad J. Obed, sir. Okay, then Associate Professor Kumar Sahu. Are you audible, sir?
Hello?
Yes.
Okay. Associate Professor Pratap Kumar Sahu from Niger. Any queries you can ask.
Yeah, some of the question I already answered. Okay. You can.
Okay.
সমস্ত খাইছে কে আসেনি মোরে ছাড়ি হবনি ସେ ସ୍ପିଚ୍ ଦେଲେ ମୋରେ ଛାଡି ହବ ଏତେ ଚାଲିଗଲା ଘର ନାଇଁ ହଁ ଅଛି କି
Okay, sir. Then you have given the answers of the question, Professor Pratap Kumar Sahu, sir.
What is the question? I didn't get it.
But you have given in the chat box, I think.
Yes, I already given many answers in the chat box. Yeah.
Okay. Then there is no queries about you. Okay, sir. Then now I will ask our next lecturer, that is Shweta Padmasini Patra, to give the vote of thanks.
A very good afternoon to all.
It gives me an immense pleasure to deliver the vote of thanks for this event to all dignitary participants. I would like to thank our spokespersons, Professor Ahmad J. Obe, Associate Professor Pratap Kumar Sahu, and Professor Samar Bagchi for their valuable talks. I would like to thank our beloved BC, Professor Madhusmita Das, Principal, staff members, students, participants, and last but not the least, our beloved press and media for making this function as a great success. Once again, I thank one and all present here and those who have participated in this event. Lastly, I request all the participants to fill the feedback form in the chat box. Thank you.
Okay, madam. Thank you, ma'am. Now I will give the chance to.
Excuse me, sir. I have a doubt, sir.
Okay.
Sir, I have a doubt for Sahu, sir.
Okay, Pratap Kumar Sahu, sir, Associate Professor. Sir,
Yes.
one doubt from participants. Can you answer? Okay, sir. Okay, ask.
Yes, sir. Previously, I have asked that how can we repeat, how can we subdivide that two photon absorption, sir? Sir, but is it possible? Because for many energy levels, we have.
No, in that way it is not possible. Okay, it has to be quantum of a particle. That means it has to be the total energy gap. Okay, if two photons, then the energy exactly that two photon energy has to be there. That means Eg by 2. Eg by 4 photon absorption. Okay, that is already called as many photon absorption. Okay, so that should not have any meaning here. Okay, yeah. So there is no experiment has been done with 4 photon absorption or 6 photon 3. It is not possible. Okay, it has just Eg by 2, Eg by 4, Eg by 8. It may be possible, but no experiment has been done yet. Yeah.
Next question.
Sir, for example, if the time is.
Yeah, it is a multiple.
Sir, can I proceed further?
Yeah, it is a multiple of this photon energy. Okay, so it cannot be any other number. And second thing is the experiment is not possible because that certain that energy pulse has to be there. Okay, so pulse laser having the same energy has to be available. Otherwise, it's not possible. Yeah.
Sir, can I ask a question from relativity?
Okay, sir.
Professor, can I ask a question from relativity?
To me?
Yes, yes, sir.
Okay, if it is very general, maybe, but yeah, you just ask. Yeah.
Sir, in classical mechanics, the mass doesn't vary, but at higher velocity, mass doesn't vary, but doesn't remain constant, as m is equal to gamma m naught. My question is, if we move higher and higher velocity, the mass will increases. After reaching a fixed mass, if we retarded the velocity, then it will be go back to it's our initial state. Is it possible? Like if I give an example on length contraction, if a meter stick move with a velocity approximately at 0.99 c, it may be contracted. But after somehow if we decrease the velocity, then can we get the initial meter stick?
Yeah, that I cannot exactly say. Okay, but according to the principle of this mass and this like length contraction, if the mass keep on increasing, you are telling, okay, so it cannot increase to a unlimited mass. Is it possible to increase the mass unlimited? And second thing is the mass del of m naught is very, very small. Okay, it is very, very small. Okay, you cannot go in the level of kilogram or milligram. It is very, very small. Okay, so that is reversible process.
Okay, sir. Thank you. Yeah. Now you can tell about this webinar, sir. tell some
Okay,
words.
it was nice.
about
Thank you very much for this webinar. Yeah, I enjoyed actually First Bakchi's interesting experiments. Okay, it was very nice. Okay, and yeah, thank you for the organization.
Okay, thank you, sir. Now, Samar Bakchi, sir, can you hear me? Samar Bakchi, sir. Okay, then now Professor Ahmad J. Abed from Iraq. Are you present, sir?
Yes, yes, sir.
Okay,
thank
sir.
you very much for organizer of this webinar, and thank you for other professors who present their sessions. I really got some knowledge about their subjects, and thank you for the organizer to inviting me for present my subjects in this webinar, and all the best in the future.
Okay, sir. Thank you. Sir.
Thank you. Thank you.
Last but not the least, sir, again we will see if the time will permit or the webinar will arranged by our institution.
Okay. Yes, yes. I wake up early because I wake up at 6 o'clock in my time because different time zone with India. So
Okay.
no problem. Thank you. You please let me know if there is any future like webinars. I am really interested to attend your webinars.
Okay.
Even
Sir, so
it's
many,
different subjects.
sir, so many students of our college also writing some articles. Sir, you can edit it and you can also give in the Scopus journal, sir, if possible.
Yes, yes. It's my pleasure because I am managed up to this month. I managed 9 international conferences. Already 6 conferences has been done, and publishing is the Scopus journals. Currently, I have 2 international conferences with the IOB Journal of Physics. I think this is the better journal for that fulfill the requirements of your students, because it's also Scopus journal, and it is also cheap one. I think the cost when you are compared with others, it comes to I think $100 if we can. But my support to Indian peoples, we are only charging the actual cost of that journals. $70 for each accepted articles. This is my supports. So
Okay,
yeah, because this is a paid journal, not a free journal. But I think 70 is acceptable by and cheap cost if you are compared with other journals. I think it is good choice if someone interested to publish his work with us. You please let me know. I will share all the support tools and things to accept his papers.
Sir, please provide your email ID so that students can give the written material or whatever work they have done. Then they will send on your email.
Yeah, sure. I will share with you maybe in the public group here in chatting. I will share the both conferences URL. You can easily join there and submit your work with us. You just let me know if they are from your institute. I will take care about them to this discount the cost of accepting the articles from your college. So I will take care about this, because actually the conference charging the little bit $150, but for you, no, I will take care to charging only the actual cost of that journal itself. And as I told you before, it's a journal of physics. It's I think it's very close to your department subjects and also your researchers.
Okay.
And also it is UK publisher. So I think it is good choice. I will take care about that.
Okay, sir. Thank you, sir.
You're welcome, sir. You're welcome. Thank you very much for your invitation.
Okay. Sir, students or participants, those who have not filled up the feedback form, you can fill up the feedback form from the chat box, which is given in the Zoom and also in the YouTube. Thank you all. Now we'll end the meeting for all.